Part 3. Modern and Advanced Enterprise Data Governance.
In this, our final session, this video, Part 3, represents the absolute peak of the data governance profession. This is where we transition to executive boardroom advisory and next-generation enterprise AI architecture. We will build end-to-end corporate roadmaps, manage high-stakes executive conflicts, and explore the hyper-modern governance of model context protocols, data clean rooms, and agent-to-agent autonomous workflows.
What we have mastered so far: scenarios 1 to 280.
Across Part 1 and Part 2, we have built an elite multidisciplinary baseline by solving 280 scenarios. Strategic Foundations Categories 1 to 4, Operating Models, Data Quality Standards, Active Metadata, and Master Customer Identity Resolution. Platform Engineering Categories 5 to 7, Multi-Cloud Data Security, Privacy as Code, and Automated End-to-End Metadata-Driven Lineage. AI and Algorithmic Guardrails Category 8, Securing LLMs, Vector Database Classifications, Prompt Injections, and Algorithmic Bias. Operational Strategy and Tools Categories 9 to 16, Federated Stewardship, Dynamic Masking, Dashboard Observability, and Tool-Specific Troubleshooting. We are now ready to cross the final frontier of our curriculum in Part 3. In case, if you missed Part 1, and Part 2 means please check links in the description below.
Part 3 Curriculum Overview Scenarios 281 to 370.
Here are the 6 advanced categories we will master in the final installment of this series. Category 17, Next Generation AI-Driven Governance, Autonomous Workflows, Synthetic Data, and Graph AI. Category 18, Enterprise Governance Design, Building Roadmaps for Multi-Cloud, M&A, and AI-First Organizations. Category 19, Executive and Boardroom Scenarios, Defending Budgets, Proving ROI, and Managing C-Suite Conflicts. Category 20, Cross-Domain Combinations, Resolving Complex Multi-Layered Architectural and Privacy Dilemmas. Category 21, Hyper-Modern Data Governance, Securing RAG Systems, Vector DBs, and the EU AI Act. Category 22, Enterprise AI Governance Architecture, Governing MCP servers, A2A communication, and AI FinOps. Check the video description below for the direct links to Part 1 and Part 2, and let's dive into Category 17.
Category 17. Next Generation Enterprise AI Governance and Autonomous Systems.
Artificial intelligence is rapidly reshaping enterprise data governance. Organizations are no longer governing only static databases and dashboards. They must now govern AI agents, RAG systems, vector databases, autonomous workflows, synthetic data, and AI memory retention. This section focuses on the hyper-modern AI governance challenges that enterprise architects are already encountering as AI becomes deeply embedded across mission-critical business operations.
Category 17. Next Generation Enterprise AI Governance and Autonomous Systems 281 to 296.
Here are the 16 advanced AI governance scenarios we will master in this category. Scenario 281. AI agents autonomously provisioning thousands of unapproved enterprise data assets. Scenario 282. Certifying AI-generated synthetic data before production decision-making. Scenario 283. Governing offline AI models running continuously at the edge. Scenario 284. Halting autonomous AI agents from dynamically modifying active data contracts. Scenario 285. Using LLMs to automatically build and maintain corporate business glossaries. Scenario 286. Deploying Graph AI to discover hidden, undocumented data relationships. Scenario 287. Securing and tracking data shared across agent-to-agent A2A communications. Scenario 288. Remediating undocumented pipelines generated by enterprise AI coding assistants. Scenario 289. Governing proprietary data in collaborative federated AI models. Scenario 290. Resolving the risk of AI copilots automatically granting data access permissions. Scenario 291. Preparing enterprise models for mandatory regulatory AI governance audits. Scenario 292. Building real-time governance for dynamically negotiated autonomous schemas. Scenario 293. Designing deterministic human-in-the-loop gates for autonomous AI decisions. Scenario 294. Deploying automated AI safety gateways to block ethical and policy violations. Scenario 295. Governing state drift and synchronization in enterprise digital twin platforms. Scenario 296. Governing AI memory retention to satisfy the right to be forgotten. Total 16 hyper-modern scenarios. Let's launch Scenario 281.
Scenario 281. A multi-agent AI system deployed to optimize global supply chain routing has autonomously generated thousands of intermediate enterprise data assets, including iceberg tables, materialized views, and vector indexes, without metadata tags or owner assignments. This shadow activity bloats cloud storage costs by $50,000 monthly and creates massive compliance gaps. How would you regain governance over autonomous AI provisioning?
Answer: governing autonomous AI agents requires shifting from human-centric policies to infrastructure-level agent constraints. I would regain control using these 4 steps. 1. Enforce agent service principal boundaries. Restrict the AI agent service principle to a dedicated, ephemeral database schema where global write privileges are strictly isolated from master production data. 2. Mandate metadata on write. Implement infrastructure as code policies requiring every data asset generated by an AI agent to structurally include agent_ID and task_ID metadata tags before the commit succeeds. 3. Deploy time-to-live TTL automations. Configure the agent schema with automated TTL parameters, ensuring any intermediate feature store objects or staging views are forcefully purged after 24 hours to eliminate compute waste. 4. Implement agent activity observability. Stream the agent's active query logs into an anomaly detection monitor, triggering an immediate kill switch if the agent exceeds its allowed data generation quota. Pro tip: treat autonomous AI agents exactly like human developers. If a human engineer is not allowed to create undocumented, untagged tables in a production warehouse, an AI agent must be blocked by the exact same database-level DDL restrictions.
Scenario 282. Your data science team generated a massive synthetic dataset to bypass strict privacy laws during model training. However, the legal department blocks its use for production decision-making, fearing the synthetic data suffers from model collapse or contains subtle re-identification vulnerabilities that could lead to catastrophic class action lawsuits. How do you govern and certify synthetic data for production use?
Answer: I would treat synthetic data not as a privacy loophole, but as a high-risk derived asset requiring rigorous cryptographic certification. First, I would mandate a strict differential privacy audit. We run mathematical distance metric evaluations to definitively prove that no individual record from the original seed data can be reverse engineered or isolated from the synthetic set. Second, we execute a membership inference attack simulation, utilizing our red team to actively attempt to re-identify individuals. Only datasets that pass these aggressive adversarial tests are granted a certified synthetic metadata badge in our catalog, satisfying legal risk requirements while unblocking the data science workflow. Pro tip: always inject digital watermarks into your synthetic datasets. By subtly embedding specific statistical anomalies or dummy records into the synthetic set, you can mathematically prove to an auditor whether a downstream model was trained on genuine private data or your safe, governed synthetic replica.
Scenario 283. Your enterprise deploys autonomous drones equipped with lightweight computer vision models to inspect hazardous mining facilities. Because these models run entirely offline at the edge, central governance has zero visibility into their algorithmic drift, leading to a situation where uncertified, degraded models are making high-risk safety decisions. How do you govern AI operating at the disconnected edge?
Answer: governing disconnected edge AI requires implementing local fail-safes and asynchronous telemetry synchronization. I would deploy the following edge governance architecture. 1. Embed local confidence thresholds. Hardcode the edge model to evaluate its own prediction confidence locally. If confidence drops below 95%, the drone automatically halts autonomous operations and requests manual human override. 2. Deploy edge-level model registries. Maintain a lightweight registry on the device itself that cryptographically verifies the model's version hash upon boot, refusing to execute if the model lacks an active certification signature. 3. Implement asynchronous telemetry syncs. Configure the device to cache its prediction logs, inference telemetry, and decision outcomes locally, automatically pushing these audit logs to the central catalog the moment it reconnects to the enterprise network. 4. Establish time-bound model expirations. Program the edge model with a hard-coded expiration date, forcing the device to return to the network for a mandatory performance and bias audit before it is allowed to continue operations. Pro tip: edge governance requires graceful degradation. If an edge AI model cannot reach the central server to verify its compliance status or refresh its logic, it must be programmed to safely shut down or revert to a highly restrictive, deterministic rule set to prevent runaway physical hazards.
Scenario 284. An advanced AI orchestration tool is deployed to optimize network latency across your microservices. To increase speed, the AI autonomously alters the API endpoints and JSON schema expectations between two core financial services without notifying downstream teams, causing critical reporting dashboards to break silently. How do you halt autonomous agents from dynamically modifying active data contracts?
Answer: I would resolve this destructive autonomy by enforcing a strict immutable contract registry governed by policy as code. AI agents cannot be permitted to execute schema modifications independently. They may only propose them. I would restrict the orchestration tool's permissions so that any schema change generates an automated pull request containing the new proposed data contract. This pull request automatically triggers a CI and CD impact analysis to map downstream dashboard dependencies. Only after the automated test proves no downstream breakages will occur, and a designated human data steward clicks approve, is the AI allowed to commit the optimization to the production environment. Pro tip: treat data contracts as the supreme law of your architecture. Use tools like schema registry to strictly enforce backward compatibility. If an AI agent attempts to drop a mandatory column or alter a data type that violates the active contract, the message broker must reject the payload instantaneously at the network boundary.
Scenario 285. To save an estimated 5,000 hours of manual stewardship, the Chief Data Officer mandates the use of an enterprise LLM to read all database SQL scripts and automatically write the corporate business glossary. However, the AI hallucinates several critical financial definitions, creating widespread organizational confusion. How do you safely govern AI-generated business glossaries?
Answer: safely automating glossary generation requires treating the LLM as an assistive drafter rather than an authoritative decision maker. I would implement this governed AI drafting workflow. 1. Restrict the LLM context window. Ground the AI model exclusively on verified enterprise artifacts, such as existing ERP documentation, verified DBT models, and regulatory filings, blocking it from pulling generic definitions from the public internet. 2. Enforce metadata confidence tagging. Configure the catalog to automatically flag all AI-generated definitions with a visible AI drafted or pending review watermark, explicitly warning business users that the term is not yet certified. 3. Implement human-in-the-loop approval. Route the AI-generated drafts directly to the designated domain steward's dashboard, transforming their job from writing definitions from scratch to quickly reviewing, editing, and approving the AI suggestions. 4. Automate synonym and drift detection. Repurpose the LLM to scan the approved glossary against live user queries, automatically alerting stewards if business users are utilizing slang or synonyms that diverge from the official terminology. Pro tip: AI is spectacular at logical to physical mapping. Instead of asking the AI to define what gross revenue means, ask the AI to scan thousands of SQL logs to find exactly which physical database columns are being joined to calculate gross revenue. This utilizes the AI for pattern recognition rather than abstract reasoning.
Scenario 286. Following a massive corporate acquisition, your enterprise is left with 10,000 undocumented, siloed tables across 3 different cloud data warehouses. Traditional metadata crawlers only show the physical schemas, but leadership needs to know how this data actually connects to identify redundant systems. How would you deploy Knowledge Graph, AI, to discover these hidden data relationships?
Answer: I would unravel this fragmented landscape by deploying graph neural networks GNNs to map the behavioral reality of our data, not just the physical schemas. First, I would ingest millions of historical query logs, BI access patterns, and user session data into a graph database. The Knowledge Graph AI analyzes these access patterns to infer primary and foreign key relationships that were never explicitly defined in the database code. For example, if users frequently join a specific table in AWS with a table in Azure using a shared string format, the AI instantly highlights this undocumented bridge. We then use clustering algorithms to group these 10,000 tables into logical business domains, allowing our architecture team to safely identify and decommission redundant databases with absolute confidence. Pro tip: Knowledge Graph AI is the ultimate tool for discovering shadow integration. Often, departments create manual CSV exports to bridge two systems. By mapping data value distributions across the enterprise, Knowledge Graph AI can flag when a standalone table in one department is actually an undocumented clone of a master table in another department.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details: 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip: whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 287. A swarm of autonomous enterprise AI agents are continuously collaborating to fulfill complex customer requests. However, security discovers that an HR AI agent passed sensitive employee salary context directly to an unclassified logistics AI agent during a multi-step prompt execution, completely bypassing standard API access controls. How do you govern and secure agent to agent A2A communication?
Answer. Governing A2A communication requires establishing machine identity protocols and payload tokenization to ensure AI agents cannot share data outside their permitted scopes. I would implement the following A2A framework. 1. Enforce mutual agent authentication, MTLS. Require every AI agent to possess a unique cryptographic identity certificate, ensuring that Agent A explicitly verifies the clearance level of Agent B before opening a communication channel. 2. Deploy semantic payload firewalls. Route all A2A text and token exchanges through an internal AI gateway that utilizes named entity recognition to dynamically scrub or block PII transfers between differently classified agents. 3. Establish A2A data contracts. Treat agents exactly like microservices. Require strict policy as code definitions that explicitly state what data schemas the HR agent is legally permitted to broadcast to external systems. 4. Log comprehensive conversational lineage. Capture the entire multi-agent prompt chain, detailing exactly which agent requested the data, what context was provided, and the final combined output, storing it in an immutable audit vault. Pro tip: use data passports for A2A transactions. When a secure agent hands a data payload to another agent, it attaches an encrypted metadata passport detailing the data's sensitivity and time to live. If the receiving agent lacks the clearance specified in the passport, its own execution environment forcefully drops the payload.
Scenario 288. Your data engineering teams are aggressively using enterprise AI coding assistants to write complex Airflow DAGs and DBT transformations. While development speed has doubled, the AI is generating hyper-optimized but completely unreadable, undocumented data pipelines, creating a massive technical debt bomb and breaking enterprise lineage maps. How do you govern AI-generated code pipelines?
Answer: I would diffuse this technical debt bomb by shifting our governance strategy to prompt reversal and strict CI and CD linting. Instead of banning AI assistants, we enforce a strict development standard. If the AI writes the transformation logic, the AI must also be prompted to generate the accompanying open lineage YAML definitions and comprehensive docstrings. We then implement automated pull request guards in our version control system. If an engineer attempts to merge AI-generated pipeline code that lacks standard data quality assertions, catalog descriptions, or schema definitions, the build automatically fails. This forces the engineer to use their AI copilot to write the governance documentation before they are permitted to push the code to production. Pro tip: treat AI-generated code as untrusted third-party code. Establish an automated peer review requirement specifically for complex SQL or Python generated by LLMs. As AI assistants frequently hallucinate table joins or invent non-existent database functions that pass syntax checks, but fail catastrophically during runtime execution.
Scenario 289. A consortium of 5 international banks agrees to train a shared, global fraud detection model using collaborative federated AI. While raw customer PII never leaves the individual bank's local servers, your chief information security officer fears that proprietary trading signals could be reverse engineered from the shared model gradients, risking a massive data leak. How do you govern cross-organization, federated AI models?
Answer: governing federated learning requires protecting the mathematical gradients in transit and auditing model convergence. I would design the consortium's governance framework using these 4 security pillars. 1. Enforce homomorphic encryption. Encrypt the model weights and gradients before they are transmitted to the central aggregating server, allowing the global model to learn and combine parameters without ever decrypting the underlying values. 2. Deploy differential privacy noise. Inject mathematically calibrated noise into each bank's local model updates. This protects against gradient leakage attacks by ensuring that no single customer's data can be isolated from the shared model. 3. Establish a secure aggregation enclave. Host the master model inside a neutral, third-party confidential computing enclave where hardware-level memory encryption prevents even the host administrator from observing the model updates. 4. Execute consortium-level data contracts. Require all participating banks to sign and adhere to identical data quality and formatting contracts, ensuring that poor data hygiene at one bank does not poison the shared global model. Pro tip: collaborative federated AI introduces data poisoning risks. A malicious or negligent partner could submit corrupted gradients to intentionally degrade the global fraud model. You must implement robust anomaly detection on all incoming gradients, automatically dropping any updates that severely deviate from the consortium's statistical baseline.
Scenario 290. Your organization deploys an advanced generative AI security copilot intended to streamline IT operations. Employees begin asking the chatbot for access to sensitive Snowflake schemas via natural language requests. The AI copilot, trying to be helpful, automatically generates the SQL grant commands and provisions the access, leading to catastrophic, unauthorized privilege escalations. How do you resolve this AI-driven security breach?
Answer: I would immediately revoke the AI copilot's direct database execution privileges and redesign the system to separate probabilistic recommendations from deterministic execution. Generative AI is inherently probabilistic and should never be granted the authority to execute identity and access management (IAM) changes directly. I would reconfigure the copilot to act purely as an access drafter. When an employee requests access, the AI drafts the specific policy request and submits it to a formal IT ticketing system. A deterministic, rule-based IAM framework evaluates the request against our role-based access control RBAC policies and requires a human data owner to click approve before any SQL commands are executed against the warehouse. Pro tip: AI should be used to audit permissions, not grant them. Deploy your security LLM to analyze millions of access logs to identify overprivileged users and recommend access revocations based on dormancy, turning the AI into a powerful zero-trust auditor rather than a dangerous administrator.
Scenario 291. Strict international regulations are enforced, and your organization officially classifies its automated insurance pricing algorithm as a high-risk AI system. The regulation mandates formal certification, threatening fines measured as a percentage of global annual revenue for non-compliance. How do you prepare your enterprise models for mandatory AI governance audits and certifications?
Answer: achieving regulatory AI certification requires moving from ad hoc data science practices to fully documented, enterprise-grade model governance. I would prepare the organization using these 4 critical steps. 1. Establish a comprehensive AI inventory. Deploy automated network scanners to discover, classify, and register every active machine learning model across the enterprise into a central, auditable registry. 2. Generate standardized model cards. Mandate that all high-risk models produce formal model cards detailing their intended use case, performance metrics, known limitations, and precise architectural boundaries. 3. Lock and audit training lineage. Freeze the specific versions of the training datasets utilized for the algorithm, ensuring we can provide regulators with absolute cryptographic proof of data provenance and consent. 4. Form a board-level AI risk committee. Elevate AI accountability by establishing a cross-functional risk board containing legal, governance, and security leaders to formally sign off on high-risk models prior to deployment. Pro tip: global AI regulators are heavily focused on human oversight. You must explicitly document and prove to auditors exactly how human operators can interpret the model's outputs and demonstrate the physical kill switch mechanisms designed to halt the AI if it acts unlawfully.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 292. In an effort to maximize data fluidity, your architecture team deploys a framework where autonomous streaming systems negotiate data schema formats dynamically during their API handshakes. While highly efficient, this completely blindlines your central data catalog, making schema tracking and downstream impact analysis impossible. How do you build real-time AI governance for autonomous data contracts?
Answer: I would regain visibility by enforcing an approved boundary matrix combined with dynamic serialization protocols. Autonomous systems cannot be allowed to negotiate infinite schema variations. Instead, we implement a central schema registry loaded with pre-approved, backward-compatible schema evolutions using strict formats like protobuf or avro. When the autonomous systems handshake, they are forced to select a data contract strictly from this predefined registry. The registry instantly broadcasts the negotiated contract to the central data catalog via a webhook, ensuring that our enterprise lineage maps update dynamically in real time while remaining perfectly governed. Pro tip: implement contract expiration. Even if an autonomous schema negotiation is successful, set a metadata flag that requires the negotiated data contract to be formally reviewed by a human data architect within 30 days to ensure long-term architectural stability.
Scenario 293. Your company utilizes an AI engine to autonomously approve and process healthcare insurance claims. However, an audit reveals the AI is silently denying complex claims that require nuanced medical context, leading to patient harm and massive liability. How would you design a deterministic human-in-the-loop governance gate for autonomous AI decisions?
Answer: governing autonomous decision-making requires embedding strict, mathematically defined confidence thresholds directly into the execution pipeline. I would design the gate using these 4 steps. 1. Define algorithmic confidence thresholds. Hardcode the AI to evaluate its own prediction certainty. Any claim prediction scoring below a 98% confidence interval is automatically suspended from autonomous processing. 2. Deploy exception routing queues. Route suspended claims directly into a prioritized dashboard for human domain experts, for example, licensed medical adjusters, to manually review and adjudicate. 3. Implement randomized auditing samples. Even for claims that pass the 98% confidence threshold, force the system to randomly divert 5% of all automated decisions into a blind human review queue to continuously test model accuracy. 4. Establish continuous bias monitoring. Analyze the demographics and medical codes of the manually overridden claims to detect if the AI is systematically struggling with specific protected patient populations. Pro tip: when human experts override an AI decision, you must capture the reason code for the override. This metadata is the most valuable asset you own, as it is fed directly back into the training pipeline to permanently correct the model's blind spots.
Scenario 294. A customer-facing generative AI agent designed to provide retail product support occasionally goes off script, offering unethical financial advice and using discriminatory language, causing severe public relations disasters. How do you automatically detect and block ethical and policy violations in generative AI outputs in real time?
Answer: I would block these violations by deploying an AI safety gateway architecture. We cannot rely on the primary customer-facing LLM to police itself. Instead, I would introduce a secondary, lightweight evaluator model that sits directly between the primary AI and the customer. This evaluator model is explicitly trained on our corporate ethics policies, legal boundaries, and acceptable use guidelines. Its only job is to intercept the primary LLM's generated response in milliseconds and assess it against our safety framework. If the response violates an ethical rule, the evaluator instantly blocks the output, logs the incident, and serves the customer a safe, pre-approved fallback message. Pro tip: Treat AI ethics breaches as P1 cybersecurity incidents. If your evaluator model detects a severe violation, such as generating hate speech or exposing corporate secrets, the primary AI agent must be automatically taken offline and disconnected from public access until the engineering team clears the prompt injection vulnerability.
Scenario 295. Your manufacturing enterprise utilizes a massive digital twin platform to simulate global supply chain routing. However, severe state drift has occurred. The virtual twin is operating on data that is 24 hours older than physical reality, causing the AI to issue disastrous shipping commands to the real-world fleet. How do you govern state drift and synchronization in enterprise digital twin platforms?
Answer: governing digital twins requires enforcing absolute temporal synchronization and physical to virtual telemetry contracts. I would establish the following governance framework. 1. Enforce state synchronization contracts. Deploy strict data latency contracts between the physical IoT edge devices and the central digital twin, immediately halting simulations if the sync latency exceeds 60 seconds. 2. Implement reality reconciliation checks. Build automated pipelines that continuously compare the twin's assumed state against the physical ERP system's verified ledger, alerting operations to any divergence. 3. Establish write-back governance. Prohibit the digital twin from issuing direct execution commands to physical machines. It must output proposed actions to a governed middleware layer that re-verifies physical safety constraints before execution. 4. Deploy temporal version control. Ensure the digital twin platform stores immutable, timestamped snapshots of its state, allowing engineers to rewind the simulation to find exactly when the virtual environment decoupled from physical reality. Pro tip: the biggest risk with digital twins is data loop corruption, where the twin simulates a scenario, writes that hypothetical data back to the central warehouse, and then accidentally re-ingests its own simulation as reality. You must enforce strict metadata segregation, ensuring simulated data is never mixed with physical telemetry ledgers.
Scenario 296. Enterprise AI assistants are now remembering previous conversations, customer interactions, and internal business decisions for months. A customer invokes their right to be forgotten, but your team realizes the customer's PII is permanently baked into the long-term semantic memory of multiple AI copilots. How do you govern AI memory to satisfy privacy regulations and retention policies?
Answer: I would govern AI memory by establishing a memory compartmentalization and decay architecture. First, we strictly forbid the AI from storing long-term context within the core model weights. Instead, AI memory is stored externally in a governed vector database. This allows us to implement semantic purge mapping. When a customer invokes the right to be forgotten, we trace their global ID, locate the specific vector chunks containing their conversational history, and physically delete those vectors. Second, we implement user-level isolation, ensuring an AI assistant's memory of one user's session can never bleed into another user's context window. Pro tip: treat AI memory exactly like a traditional database. Apply time-to-live TTL metadata tags to all conversational vector embeddings, so that routine chat history automatically decays and is purged after 30 days, drastically reducing your legal discovery footprint.
Category 17 Conclusion.
Mastering enterprise AI governance shifts the focus from managing static tables to securing dynamic, autonomous agents and generative workflows. By enforcing metadata on write, certifying synthetic data, and deploying AI safety gateways, you protect the enterprise from catastrophic algorithmic liabilities while unlocking the massive speed and scale of AI-driven innovation.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass. You send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 17 to Category 18.
Understanding hyper-modern AI components is crucial, but true enterprise architects must know how to assemble these pieces into a comprehensive, multi-year strategic roadmap. We now zoom out from specific technologies to focus on large-scale business transformations. Whether you are scaling a startup or recovering from a cyber attack, we move to the architectural blueprint phase. Category 18. Enterprise Data Governance Design Scenarios.
Category 18. Enterprise Data Governance Design Scenarios.
This category tests your ability to design end-to-end governance operating models for massive corporate transformations. From guiding a Fortune 500 company into an AI-first operating model and securing a multi-cloud banking ecosystem, to recovering from a devastating data breach or regulatory audit. These case study scenarios require high-level strategic thinking, phased execution, and boardroom-ready communication.
Category 18. Enterprise Data Governance Design Scenarios 297 to 304.
Here are the 16 enterprise design case studies we will master in this category. Scenario 297. Designing an enterprise governance roadmap for an AI-first Fortune 500 organization. Scenario 298. Designing a scalable data governance framework for a hyper-growth global startup. Scenario 299. Rebuilding enterprise data governance from scratch after a major cyber data breach. Scenario 300. Designing governance boundaries for an AI-powered healthcare diagnostics platform. Scenario 301. Architecting a unified governance model for a multi-cloud global banking ecosystem. Scenario 302. Building a secure enterprise framework for internal generative AI and Copilot adoption. Scenario 303. Designing telemetry governance for industrial IoT and smart manufacturing plants. Scenario 304. Governing fragmented enterprise master data across 50-plus decentralized SaaS applications. Scenario 305. Designing an MDM and governance plan for a customer 360 transformation program. Scenario 306. Building robust governance for a global enterprise data as a service marketplace. Scenario 307. Designing pre-migration governance for a massive legacy to cloud data migration. Scenario 308. Building a unified governance framework following a massive global merger and acquisition. Scenario 309. Designing cross-system governance for enterprise autonomous AI agent ecosystems. Scenario 310. Building a data product governance framework to support an enterprise data mesh. Scenario 311. Designing a governance recovery and remediation strategy after a failed regulatory audit. Scenario 312. Designing a governance operating model for enterprise data products across business domains. Total 16 enterprise design scenarios. Let's dive into Scenario 297.
Scenario 297. A Fortune 500 CEO mandates a massive corporate pivot to an AI-first operating model within 18 months, but the current data landscape is heavily siloed and undocumented, preventing any models from scaling safely. How do you design the enterprise governance roadmap to support this transformation?
Answer: transitioning to an AI-first architecture requires a phased roadmap that prioritizes certification and automated metadata collection. I would execute the following 4 phases. 1. Phase 1. Establish AI-ready foundations. Deploy automated cataloging tools to inventory, classify, and assign ownership strictly to the critical data elements required for initial AI use cases. 2. Phase 2. Deploy shift-left quality gates. Embed automated data contracts and privacy checkers directly into the engineering CI and CD pipelines to ensure data is clean and compliant before it enters the warehouse. 3. Phase 3. Build a certified AI feature store. Establish a centralized, governed repository of curated features, ensuring data science teams only train models on fully vetted, peer-reviewed data. 4. Phase 4. Enforce continuous algorithmic auditing. Implement post-deployment monitors to track model drift, fairness metrics, and feature importance logs to guarantee ongoing compliance. Pro tip: do not attempt to boil the ocean and catalog the entire enterprise at once. Target 3 high ROI AI use cases and build your governance roadmap entirely around certifying the specific data pipelines feeding those models, creating a repeatable AI-ready blueprint.
Scenario 298. A hyper-growth software startup is expanding globally ahead of an IPO. Their current data governance consists of ad hoc scripts and informal Slack agreements, creating massive privacy and compliance risks. How do you design a scalable data governance operating model for this transition?
Answer: scaling a startup requires balancing compliance with engineering velocity. I would establish a scalable, developer-friendly governance model using these steps. 1. Deploy minimum viable governance (MVG). Focus the initial 90 days exclusively on high-risk compliance controls, implementing automated PII masking and establishing strict role-based access controls. 2. Transition to a federated hub and spoke. Create a small central governance team, the hub, to define global privacy standards, while empowering embedded data champions the spokes to enforce them within their agile squads. 3. Implement governance as code. Migrate policy enforcement into Terraform and dbt pipelines, allowing developers to configure metadata tags and access rules directly in their code repositories. 4. Centralize cloud cost governance FinOps. Deploy automated monitors to track compute consumption by data product, establishing financial accountability to curb aggressive startup cloud waste. Pro tip: hypergrowth engineers will aggressively reject bureaucracy. Embed governance entirely within their existing Git and CI and CD workflows. If your governance strategy requires a developer to log into a separate administrative UI to request approvals, it will fail adoption.
Scenario 299. A sophisticated cyber attack successfully exfiltrated millions of unencrypted customer records from a forgotten shadow database. The board has fired the previous leadership and hired you to rebuild enterprise data governance from the ground up to restore regulator and public trust. What is your strategy?
Answer: I would execute an aggressive zero-trust discovery and lockdown strategy. In a post-breach environment, the immediate priority is not writing PDF policies, but active infrastructure scanning to locate, classify, and quarantine all remaining shadow IT and dark data silos. Once the perimeter is secured, I would establish a strict default deny access paradigm utilizing attribute-based access control back, ensuring no data is accessible without a verified purpose of use tag and multi-factor authentication. Finally, I would construct a transparent, automated compliance dashboard directly accessible to external auditors to mathematically prove that the new governance controls are active and preventing secondary exposures. Pro tip: in a post-breach scenario, speed is your primary currency. Prioritize deploying automated PII detection scanners across your cloud buckets to stop active bleeding before attempting to establish complex stewardship councils or lengthy glossary definitions.
Scenario 300. A national health network is building an AI-powered diagnostic and patient care platform. The system must ingest real-time EHR records, imaging, and genomic data while navigating the heaviest HIPAA and patient safety regulations. How do you design this governance framework?
Answer: designing governance for clinical AI requires bridging strict privacy laws with rigorous medical data quality standards. I would architect the framework as follows. 1. Enforce HIPAA-compliant data tokenization. Deploy an ingestion gateway that automatically strips and tokenizes direct patient identifiers before the data ever reaches the AI training environment. 2. Establish clinical representativeness metrics. Mandate automated demographic profiling on all training datasets to detect and mitigate historical biases that could lead to diagnostic disparities. 3. Implement compute-to-data architectures. Prevent raw download of genomic or imaging files by forcing researchers to execute their AI models inside highly restricted, localized secure enclaves. 4. Deploy human-in-the-loop diagnostic gates. Hardcode the platform to route any diagnostic prediction that falls below a 99% confidence interval to a licensed physician for mandatory sign-off. Pro tip: design the system with a consent-aware ingestion layer. If a patient dynamically revokes their consent for medical research, their metadata tag must instantly trigger an automated purge of their records from the active AI training feature store.
Scenario 301. A Tier 1 global bank is executing a multi-cloud strategy across AWS, Azure, and GCP to prevent vendor lock-in, but this has resulted in fragmented security policies, broken lineage, and failing BCBS 239 risk aggregation audits. How do you design a unified governance architecture?
Answer: a multi-cloud governance strategy must rely on an abstraction layer rather than native cloud tools. I would design the architecture using these pillars. 1. Deploy a cloud-agnostic metadata layer. Implement a centralized data catalog like Collibra or Elation that bridges all three clouds, providing a single, universal data dictionary and lineage map. 2. Translate policies to cloud-native IAM. Write global access policies once in a central orchestrator like Immuta, which automatically translates and pushes them into AWS, Azure, and GCP native security roles. 3. Stitch cross-cloud lineage via open standards. Mandate that all transformation jobs emit open lineage telemetry, allowing the catalog to visually trace a dataset as it moves from an S3 bucket to a Snowflake table on Azure. 4. Enforce data sovereignty routing. Tag datasets with geographic residency metadata to dynamically block automated replication pipelines from illegally copying European data into American cloud regions. Pro tip: focus intensely on identity federation. Multi-cloud governance instantly collapses if a single employee has 3 different disconnected identities. A centralized identity provider, IDP, mapped to universal metadata tags, is mandatory for cross-cloud access control.
Scenario 302. The Board of Directors has allocated $20 million to deploy generative AI copilots across HR, legal, and finance to boost productivity. However, the CISO is threatening to block the program due to fears of prompt injections, massive IP leakage, and unauthorized data access. How do you build an enterprise governance framework to secure Gen AI adoption?
Answer: I would resolve this executive standoff by designing an AI safety gateway architecture that physically decouples the enterprise data stores from the foundational LLMs. Instead of allowing direct database querying, we route all Copilot interactions through a centralized API gateway equipped with real-time data loss prevention DLP and prompt injection scanners. Furthermore, we establish strict semantic search boundaries, ensuring the RAG system strictly inherits the Active Directory permissions of the querying user, making it impossible for a junior analyst to prompt the AI into revealing executive payroll data or unapproved legal documents. Pro tip: mandate that all Gen AI deployments utilize a zero retention API agreement with the underlying LLM provider. This provides cryptographic and legal guarantees that corporate IP, sensitive financial data, and employee prompts are never logged, stored, or utilized for future model training by the vendor.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details: 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip: Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Scenario 303. A global manufacturing giant is connecting 50,000 factory machines to a centralized smart manufacturing platform to drive predictive maintenance. However, the telemetry data is completely unstandardized, and missing edge sensor readings are causing the AI models to halt production lines unnecessarily. How do you design this industrial governance model?
Answer: governing industrial IoT requires pushing data quality enforcement to the extreme edge of the network. I would design the framework using these 4 steps. 1. Enforce edge-level schema validation. Deploy schema registries directly on the factory floor gateways to reject corrupted or malformed sensor payloads on the fly before they enter the central network. 2. Standardize time series aggregation. Build automated pipelines to instantly normalize disparate hardware timestamps into a standardized UTC format, preventing chronological misalignment. 3. Establish IT and OT data contracts. Define strict latency and quality service level agreements between the operational technology OT hardware teams and the IT data platform teams. 4. Monitor sensor calibration drift. Deploy continuous statistical profiling on incoming streams to flag degrading hardware sensors before their corrupted data poisons the predictive maintenance models. Pro tip: implement graceful fallbacks in your AI logic. If an edge sensor violates its data quality contract by transmitting consecutive nulls, the governance architecture must automatically instruct the predictive maintenance model to default to historical safety averages, rather than triggering a catastrophic, multi-million-dollar factory shutdown.
Scenario 304. Your enterprise relies on a highly fragmented ecosystem of over 50 disparate SaaS applications: Salesforce, Workday, Zendesk, Marketo, etc. This SaaS sprawl has created decentralized data silos, conflicting customer master records, and massive shadow IT risks. How do you design a strategy to govern this ecosystem?
Answer: I would execute a hub-and-spoke master data strategy fueled by API-first metadata harvesting. Because you cannot physically force 50 different SaaS applications into a single database schema, I would deploy automated cloud connectors to pull metadata from all 50 systems into a central enterprise catalog, creating a unified global data dictionary. Next, we designate specific SaaS applications as the definitive system of record for specific domains. For example, Workday exclusively owns employee data, and Salesforce owns customer data. Finally, we implement a master data management resolution engine that continuously synchronizes these golden attributes back to the downstream SaaS tools, ensuring the fragmented systems operate on a unified baseline. Pro tip: use your corporate single sign-on SSO authentication logs to perform a shadow SaaS audit. Governance cannot protect what it cannot see. Comparing your SSO logs against your official catalog inventory will instantly reveal unauthorized third-party apps processing corporate data.
Scenario 305. A retail enterprise is investing millions into a customer 360 transformation to unify fragmented identities across sales, marketing, and support. However, previous attempts failed because different departments refused to trust the unified data. How do you design an MDM and governance plan that guarantees adoption?
Answer: designing governance for a customer 360 program requires moving beyond technical integration to enforce strict survivorship and cross-functional trust. I would execute this framework. 1. Establish an enterprise semantic baseline. Define the canonical data model for the customer before any data is moved, ensuring all departments agree on the foundational attributes. 2. Deploy probabilistic identity resolution. Use machine learning-driven matching algorithms to link fragmented identities like guest checkouts and loyalty accounts across disparate source systems. 3. Enforce attribute-level survivorship rules. Configure the MDM engine so the CRM wins on contact preferences, while the ERP definitively wins on billing addresses, preventing departmental overwrite wars. 4. Implement dynamic consent synchronization. Map privacy opt-ins directly to the unified customer ID, ensuring that a do not email request captured in support instantly propagates to the marketing automation tools. Pro tip: Customer 360 is not an IT project, it is a governance project. If you do not assign a centralized data steward to manually adjudicate the 2% of complex identity conflicts that the automated MDM engine cannot confidently resolve, the entire 360-degree view will eventually degrade.
Scenario 306. Your organization wants to transition from internal data hoarding to building a global enterprise data marketplace, allowing internal business units and eventually external partners to shop for and monetize datasets seamlessly. How do you design the governance architecture to support data as a service?
Answer: I would design this marketplace by treating datasets as formal commercial products. First, we implement a highly discoverable, consumer-grade data catalog acting as the storefront, where every dataset displays a verified trust score, freshness SLA, and designated owner. Second, we establish automated data access contracts. When a user clicks subscribe on a dataset, an automated workflow evaluates their Active Directory attributes against the dataset's privacy tags, instantly provisioning masked or unmasked access without manual IT tickets. Finally, we implement usage telemetry to track which data products are consumed most frequently, providing chargeback metrics for internal teams and monetization analytics for external partners. Pro tip: to secure external monetization, implement programmatic watermarking and differential privacy at the marketplace egress layer. This ensures that any data leaving your corporate boundaries cannot be reverse engineered to expose individual PII, protecting your intellectual property and regulatory standing.
Scenario 307. The enterprise is executing a massive legacy to cloud data migration, moving petabytes of data from on-premise Hadoop clusters to Snowflake. Leadership wants to avoid simply lifting and shifting a data swamp into the cloud. How do you design the legacy to cloud governance strategy?
Answer: a successful cloud migration requires aggressive pre-migration garbage collection and metadata rationalization. I would design the strategy using these 4 phases. 1. Execute usage-based garbage collection. Analyze historical query logs on the legacy system to identify cold tables that haven't been queried in over a year, archiving them on-premise rather than paying to migrate them. 2. Enforce migration certification gates. Establish a rule that no dataset can be migrated to the new cloud platform unless it has an assigned business owner and a verified PII classification tag in the metadata catalog. 3. Automate schema modernization. Use profiling tools to identify and fix structural anomalies, such as inconsistent timestamp formats or padded strings, before the data is loaded into the target cloud warehouse. 4. Deploy parallel reconciliation pipelines. During the cutover window, run critical reports on both the legacy and modern systems simultaneously, using automated assertions to prove to executives that the cloud metrics match the legacy metrics to the penny. Pro tip: use the cloud migration as a political lever to force data ownership. Send a list of undocumented, high-cost tables to business leaders with a warning. If you do not claim ownership and justify the migration cost by Friday, these tables will be permanently archived.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 308. Your company has just acquired a massive international competitor. The two organizations have completely different data governance maturity levels, conflicting compliance standards, and incompatible data catalogs. How do you build a unified governance framework following this global merger?
Answer: I would avoid forcing an immediate, brutal physical platform consolidation, which typically causes operations to freeze. Instead, I would establish a logical canonical data model and a federated governance council containing leaders from both companies. We map both organizations' existing, disparate taxonomies to this new, neutral canonical model using our metadata catalog, allowing executive reporting to unify instantly. Behind the scenes, we perform a strict privacy crosswalk to elevate the acquired company's data security up to our baseline standards, prioritizing immediate lockdown of overlapping identity and access management vulnerabilities. Pro tip: during the initial M&A integration period, implement a strict zero-trust sandbox for cross-company data sharing. Do not blindly connect their data lake to yours. Force all shared datasets through a rigorous, automated PII scanning and dynamic masking gateway until you have fully audited their historical data hygiene.
Scenario 309. Dozens of autonomous AI agents are being deployed across HR, finance, and supply chain to interact with enterprise data stores. Security is terrified of cascading vulnerabilities if one agent is compromised. How do you design cross-system governance for an enterprise AI agent ecosystem?
Answer: governing an ecosystem of autonomous agents requires machine identity management and programmatic execution boundaries. I would design the framework as follows. 1. Enforce unique machine identities. Assign every AI agent a dedicated service principal and cryptographic identity, ensuring its database read and write activities are perfectly isolated from human user logs. 2. Implement prompt layer RBAC. Ensure that the AI agent dynamically inherits the exact role-based access control permissions of the human employee who prompted it, preventing junior analysts from using an HR agent to pull executive salaries. 3. Establish execution sandboxes. Physically restrict agents from directly executing DML commands like update or delete on master production tables, forcing them to output proposed changes to a staging layer for human validation. 4. Log immutable A2A conversations. Capture and encrypt all agent-to-agent communication payloads, storing them in a worm-compliant audit vault to trace exactly how multi-agent decisions were negotiated. Pro tip: AI agents require expiration dates. Assign a strict time to live TTL on an agent's access token. An autonomous agent should never possess permanent, standing privileges to an enterprise database.
Scenario 310. The Chief Data Officer is transitioning the enterprise to a decentralized data mesh architecture, dissolving the central IT data warehouse team. How do you govern these highly federated data products without losing enterprise compliance and quality control?
Answer: I would govern the data mesh by shifting to a federated computational governance model. In a data mesh, business domains own the data, but they must build on a standardized platform. I would deploy policy as code to automatically enforce global enterprise rules, such as mandatory encryption, PII tagging, and standard naming conventions, directly within the decentralized CI and CD pipelines. If a domain team attempts to publish a data product that fails these global programmatic tests, the deployment is blocked. This allows domains to operate with total agility while guaranteeing that every published data product is highly discoverable, interoperable, and secure. Pro tip: decouple infrastructure from ownership. The central data platform team should provide a governance-in-a-box self-service template, including pre-configured Terraform scripts and dbt models, so domain owners can spin up compliant data products instantly without needing deep data engineering expertise.
Scenario 311. Your organization just failed a massive federal regulatory audit due to missing data lineage, undocumented transformation logic, and uncontrolled access to consumer PII. The regulators have given the company 90 days to present a comprehensive remediation strategy. How do you design this governance recovery plan?
Answer: a regulatory recovery strategy must prioritize absolute transparency, high-risk quarantine, and structural automation. I would execute this 90-day remediation roadmap. 1. Execute immediate quarantine of high-risk silos. Instantly lock down and audit any undocumented shadow databases flagged by the regulators, stripping standing privileges and migrating to just-in-time access. 2. Deploy automated PII discovery. Run continuous metadata classification, scanners across the entire cloud, and on-premise estate to prove to regulators that all sensitive customer data is mapped and accounted for. 3. Build golden path lineage. Abandon trying to map the entire warehouse. Focus exclusively on reverse engineering the exact end-to-end lineage for the top 20 critical regulatory reports identified in the audit. 4. Establish continuous compliance reporting. Build an automated, read-only dashboard accessible directly by external auditors, providing real-time mathematical proof that masking policies and data contracts are active. Pro tip: regulators want to see structural change, not just fixed data. Do not just clean the broken tables. Present the auditors with the new CI and CD deployment rules that structurally prevent developers from ever pushing undocumented pipelines into production again.
Scenario 312. Moving beyond data mesh buzzwords, the executive board wants a pragmatic, actionable data product operating model. How do you define ownership, lifecycle management, and service-level agreements, SLAs, across heavily siloed business domains?
Answer: I would design the operating model by transitioning the enterprise from IT-owned projects to business-owned products. First, we mandate that every dataset exposed for cross-domain use is assigned a dedicated data product manager from the business side, who is fully accountable for its ROI, documentation, and quality SLAs. Second, we implement formal data contracts that act as binding SLAs between the producing domain and the consuming analytics teams. These contracts guarantee uptime, define strict schema structures, and establish incident response times, elevating data from a passive byproduct of an application into a managed, high-value enterprise asset. Pro tip: treat data products exactly like software APIs. Apply strict semantic versioning such as version 1.0 and version 2.0. If a domain team needs to alter a schema, they must publish a version 2.0 data product, while continuing to support version 1.0, ensuring that downstream consuming teams never experience silent, catastrophic breakages.
Category 18. Conclusion.
Mastering enterprise governance design proves that you are no longer just maintaining databases. You are architecting massive business transformations. Whether you are scaling a hyper-growth startup, recovering from a catastrophic cyber breach, or orchestrating a global multi-cloud banking ecosystem, your ability to phase, structure, and deploy an operating model is what defines an elite enterprise architect.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Transition from Category 18 to Category 19.
While designing the architectural blueprints for enterprise transformations ensures structural integrity, even the most perfect technical design will fail if it lacks executive backing and financial justification. As a data leader, your toughest battles will not be fought in the codebase, they will be fought in the boardroom. We now transition from enterprise design to executive strategy. Category 19. Executive and boardroom data governance scenarios.
Category 19. Executive and boardroom data governance scenarios.
This category elevates the conversation to the C-suite. We are focusing on defending multi-million-dollar budgets, proving hard dollar ROI to the board of directors, resolving ownership turf wars between the CDO and CISO, and transforming data governance from a perceived bureaucratic cost center into a quantifiable revenue driver. These scenarios target director, principal architect, and chief data officer interview rounds.
Category 19. Executive and boardroom data governance, scenarios 313 to 327.
Here are the 15 boardroom and executive strategy scenarios we will solve in this category. Scenario 313. Responding to a CEO who demands that data governance become a direct revenue driver. Scenario 314. Explaining a governance failure to the board after a multi-million-dollar tooling investment. Scenario 315. Building robust enterprise governance without slowing down daily business operations. Scenario 316. Accelerating enterprise AI innovation without compromising strict regulatory compliance. Scenario 317. Achieving quantifiable enterprise governance maturity within an aggressive 6-month window. Scenario 318. Embedding data governance requirements seamlessly into every new software product launch. Scenario 319. Resolving the governance ownership turf war between the CISO and the CDO. Scenario 320. Proving tangible governance value and risk reduction to external investors and the board. Scenario 321. Designing enterprise data accountability scorecards for executive reporting. Scenario 322. Creating and presenting a comprehensive 3-year enterprise data governance strategy. Scenario 323. Building an agile governance strategy to support rapid mergers and acquisitions. Scenario 324. Advising the board on whether enterprise data governance should be centralized or federated. Scenario 325. Building an executive strategy for responsible AI governance and ethical scaling. Scenario 326. Designing enterprise data trust scores for transparent executive reporting. Scenario 327. Using AI and automation to scale the governance program without growing headcount. Total 15 executive boardroom scenarios. Let's dive into Scenario 313.
Scenario 313. The CEO pulls you into a strategic planning meeting and states that the era of treating data governance purely as a defensive compliance cost center is over. They demand to know exactly how your data governance program will act as a direct revenue driver for the enterprise. How do you respond?
Answer: I would respond by shifting the narrative from data protection to data liquidity and monetization. I would explain to the CEO that governance is the engine that manufactures trust, and trusted data is a commercial product. By implementing strict semantic layers and high-fidelity master data, we drastically reduce our time to insight, allowing marketing to launch hyper-targeted, high-conversion campaigns weeks faster. Furthermore, I would introduce a framework for external data monetization, using secure data clean rooms and zero-copy sharing to securely package and sell our anonymized enterprise insights to third-party partners, creating a net new multi-million-dollar revenue stream built entirely on governed data. Pro tip: speak the CEO's language. Never use words like metadata or lineage in this pitch. Use terms like data asset liquidity, accelerated speed to market, and new revenue verticals. If you map governance directly to the top line, you will never struggle for budget again.
Scenario 314. You have just been hired as the head of data governance. The board of directors is furious because the previous leadership spent $3 million on a premium data catalog tool 2 years ago, yet adoption is at zero and data quality has actually worsened. They demand an explanation for the failure. How do you address the board?
Answer: I would address the board with absolute transparency, explaining that the previous initiative suffered from the tool-first fallacy. I would clarify that the millions were spent on software, but zero was invested in change management, process engineering, or incentive alignment. A tool is simply an empty filing cabinet, without establishing clear data ownership, integrating metadata into the developer's daily CI and CD workflows, and tying data quality to executive performance metrics. The tool became an expensive graveyard. I would then present a 90-day recovery roadmap focused entirely on business enablement, proving value on 3 critical executive dashboards before we spend another dollar on technology. Pro tip: when addressing a hostile board regarding a past failure, never blame the technology vendor. Executives view blaming the software as an excuse for poor leadership. Take accountability for the lack of operational integration and pivot immediately to your people and process remediation strategy.
Scenario 315. The executive leadership team is hesitant to endorse your new governance framework because they fear it will add massive bureaucratic red tape, slowing down agile software delivery and daily business operations. How do you architect a governance model that secures the enterprise without slowing it down?
Answer: building governance without causing operational friction requires abandoning manual review boards and moving entirely to shift-left automated architecture. I would execute this strategy. 1. Deploy policy as code. Embed data quality, privacy, and naming conventions directly into the engineering team's CI and CD pipelines, checking compliance automatically during code compilation. 2. Establish pre-cleared sandboxes. Provide business analysts with secure, governed cloud workspaces pre-loaded with certified masked data, eliminating the need for them to submit manual IT access tickets. 3. Automate metadata harvesting. Use API-driven crawlers and query log parsers to build catalogs and lineages in the background, rather than forcing engineers to write manual documentation. 4. Implement exception-based stewardship. Auto-approve 90% of routine catalog updates and system access requests via metadata rules, escalating only high-risk anomalies to human stewards. Pro tip: use the brakes on a sports car analogy with executives. You do not put massive brakes on a Ferrari because you want to drive slowly. You put them on so you can drive at 200 miles per hour safely. Automated governance is the brake system that allows developers to innovate at maximum speed without crashing the company.
Scenario 316. The board wants to aggressively launch new generative AI features to beat a competitor to market. However, the chief privacy officer warns that moving this fast will violate strict data privacy regulations. How do you design a strategy that accelerates enterprise AI innovation without compromising compliance?
Answer: I would resolve this standoff by establishing an AI safety gateway and decoupling the innovation environment from the compliance perimeter. First, I would build an isolated, highly secure AI innovation sandbox filled exclusively with certified synthetic data and rigorously scrubbed, anonymized datasets. This allows the engineering teams to build, train, and test their generative AI models at maximum velocity without any risk of leaking real PII. Second, for the production deployment, I would install a real-time constitutional AI guardrail API that automatically inspects every prompt and output against our legal privacy framework in milliseconds, ensuring that the final product is structurally incapable of violating compliance mandates. Pro tip: do not try to police the AI engineers. Govern the data they are consuming. If you guarantee that the only data physically available in their development sandbox is 100% compliant and privacy scrubbed, you can completely remove the bureaucratic brakes from their innovation sprints.
Scenario 317. Following a highly critical auditor report, the executive committee gives you exactly 6 months to visibly and measurably improve the organization's enterprise data governance maturity from ad hoc to defined. How do you execute this rapid transformation?
Answer: achieving rapid maturity requires abandoning the boil the ocean approach and executing a highly targeted minimum viable governance MVG sprint. Minimum viable governance MVG is my implementation strategy rather than an industry standard framework. I would deploy this 6-month roadmap. 1. Month 1. Identify critical data elements CDEs. Work with executives to identify the top 20 data elements that drive the company's highest risk financial and regulatory reports. 2. Month 2. Establish the ownership matrix. Assign formal, documented data owners and stewards exclusively to those 20 CDEs, avoiding the friction of a massive, company-wide restructuring. 3. Months 3 to 4. Automate lineage and quality. Deploy active metadata tools to automatically map the end-to-end lineage and deploy real-time data quality dashboards solely for those critical pipelines. 4. Months 5 to 6. Formalize and audit. Publish the certified dashboards to the executive committee, using the automated quality scores and lineage maps as mathematical proof of achieved maturity. Pro tip: never promise level 5 maturity across the entire enterprise. It is a mathematical impossibility in 6 months. Promise level 4 maturity on your 20 most critical datasets and leave the remaining 10,000 low-risk tables at level 1. Auditors reward targeted, risk-based prioritization.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Scenario 318. Enterprise product managers are launching new software applications that generate entirely new customer datasets, but they routinely launch these products without any metadata documentation, lineage tracking, or privacy tagging. How do you embed data governance seamlessly into every product launch?
Answer. I would embed governance by integrating it directly into the company's software development lifecycle, SDLC, and agile release gates. Instead of running retroactive audits after a product is live, I would work with the VP of engineering to update the formal definition of done for all agile sprints. We configure the deployment pipelines so that no new database schema or application feature can be merged into production unless the code includes an infrastructure as code configuration file defining the table owner, the data dictionary descriptions, and the PII classification tags. If the file is missing, the CI and CD pipeline automatically blocks the release. Pro tip: Treat data exhaust as a Tier 1 product feature. Educate your product managers that the data their application generates is just as valuable to the enterprise as the application's user interface. If the data is not structured, tagged, and cataloged, the software is not ready for launch.
Scenario 319. A major organizational turf war has erupted between the Chief Information Security Officer (CISO) and the Chief Data Officer (CDO). The CISO wants to lock down all data to prevent breaches, while the CDO wants to open access to drive AI analytics. Both claim ultimate authority over data governance. How do you resolve this executive ownership dispute?
Answer: I would resolve this boardroom deadlock by establishing a strict RACI matrix that formally separates infrastructure security from data context. I would mediate an agreement where the CISO owns the vault, meaning they have ultimate authority over network perimeters, encryption at rest, endpoint data loss prevention, and identity provisioning. Conversely, the CDO owns the context, having ultimate authority over metadata classifications, business glossaries, and defining which business roles are permitted to access specific data tiers. This clean division ensures the CISO builds the impenetrable fence, while the CDO determines who receives the key based on business value. Pro tip: present this operational alignment as policy orchestration. The CDO uses the data catalog to tag a column as highly confidential. The CISO's automated security architecture reads that tag and dynamically applies the masking rule. This transforms a turf war into a highly automated, symbiotic partnership.
Scenario 320. Your publicly traded company is preparing for an aggressive mergers and acquisitions M&A phase. The board of directors and external institutional investors ask you to present exactly how your enterprise data governance program reduces operational risk and increases the company's valuation. What is your executive pitch?
Answer: to prove value to institutional investors and the board, I would frame data governance as an accelerator for capital liquidity and a shield against catastrophic regulatory devaluation. I would pitch these 4 value pillars. 1. M&A integration velocity. Prove that our highly governed, metadata-mapped architecture allows us to ingest, harmonize, and report on an acquired company's data in 90 days instead of 18 months, accelerating post-merger synergies. 2. ESG and regulatory insulation. Demonstrate how our automated privacy gates and end-to-end lineage tracking mathematically eliminate the risk of massive GDPR or EU AI Act fines, protecting the company's stock price from compliance shocks. 3. Cloud FinOps efficiency. Highlight how our active metadata and automated storage lifecycle policies have stripped 20% of zombie data waste from our cloud compute bills, directly padding the bottom line EBITDA. 4. Enterprise AI readiness. Explain that institutional investors place massive valuation premiums on companies capable of deploying enterprise AI. Assure the board that our certified, bias-tested data foundation makes us fundamentally AI-ready. Pro tip: investors and board members do not care about technical data quality scores. They care about data asset liquidity, which is the metric of how fast your company can leverage its internal data to launch a new product, enter a new market, or integrate a new acquisition without the architecture collapsing.
Scenario 321. The board of directors is frustrated because when a critical financial report fails, business and IT teams constantly point fingers at each other, claiming we do not own that data. The CEO demands a transparent enterprise data accountability scorecard. How do you design and implement this executive reporting mechanism?
Answer: designing an executive accountability scorecard requires moving from abstract data quality metrics to named human accountability. I would design the scorecard using these 4 pillars. 1. Map data domains to executive owners. Divide the enterprise data landscape into logical business domains, for example, customer, product, finance, and publicly assign a specific vice president as the accountable owner for each. 2. Aggregate domain health scores. Calculate a unified data health score for each domain based on underlying data quality pass rates, active lineage completeness, and security compliance. 3. Track remediation SLAs. Measure the mean time to repair for critical data incidents within each domain, highlighting which executives are actively fixing their data and which are ignoring alerts. 4. Publish a transparent executive leaderboard. Distribute this scorecard monthly to the C-suite, using red/yellow/green visual indicators to spark competitive urgency among the executive leadership team. Pro tip: to make the scorecard truly effective, work with human resources and the CEO to tie these domain data health scores directly to the executive's annual performance bonuses. When bad data directly impacts an executive's compensation, finger-pointing vanishes and data quality becomes an immediate priority.
Scenario 322. You have just been appointed as the Chief Data Officer for a global manufacturing firm. The board asks you to present a comprehensive, 3-year enterprise data governance strategy to secure a multi-million-dollar transformation budget. How do you structure this multi-year roadmap?
Answer: a multi-year executive roadmap must demonstrate a progression from risk containment to revenue generation. I would structure the 3-year strategy as follows. 1. Year 1. Visibility and risk containment. Focus entirely on deploying active metadata catalogs, identifying critical data elements, mapping PII, and establishing the foundational data stewardship operating model. 2. Year 2. Automation and shift left quality. Transition from manual oversight to automated infrastructure. Embed data contracts into CI and CD pipelines, automate lineage extraction, and deploy dynamic masking to scale operations safely. 3. Year 3. AI readiness and data monetization. Leverage the clean data foundation to deploy trusted enterprise AI co-pilots, establish secure data clean rooms for third-party partnerships, and launch a self-service data as a service marketplace. Pro tip: always fund Year 2 and Year 3 by delivering massive quick wins in Year 1. Dedicate your first 90 days to fixing the CEO's most broken, highly visible reporting dashboard. Earning that executive trust early guarantees your budget for the rest of the 3-year roadmap.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 323. Your enterprise has announced an aggressive strategy to acquire 3 major competitors over the next 18 months. Integrating their chaotic, undocumented data systems could expose your company to massive compliance fines and corrupt your financial reporting. How do you build an agile governance strategy to support rapid mergers and acquisitions?
Answer: supporting rapid M&A requires a highly defensive integration posture and a standardized ingestion playbook. I would execute this M&A governance strategy. 1. Execute automated due diligence scans. Deploy remote discovery scanners into the target company's data environment before the acquisition closes to uncover hidden PII and undocumented cloud storage liabilities. 2. Establish a zero-trust data quarantine. Never connect an acquired company's data lake directly to yours. Route all their incoming data through a heavily monitored quarantine zone to execute mandatory malware and schema validation checks. 3. Deploy canonical mapping layers. Instead of forcing immediate database consolidation, map the acquired company's local schemas to your enterprise's canonical master data model using virtual views to achieve instant reporting integration. 4. Enforce security baseline uplifts. Instantly overwrite the acquired company's legacy access roles with your enterprise's modern attribute-based access control policies to close backdoor vulnerabilities. Pro tip: deploy data clean rooms during the transitional M&A phase. This allows analysts from both the parent company and the acquired company to securely query joint customer overlap and calculate synergies before the corporate network perimeters are formally merged.
Scenario 324. A massive debate breaks out in the boardroom. The Chief Information Officer argues that data governance must be strictly centralized under IT to ensure security, while business unit leaders demand complete decentralization to maintain agility. The CEO asks you to advise the board. Should enterprise data governance be centralized or federated?
Answer: I would advise the board that neither absolute centralization nor total decentralization works in a modern enterprise. The only scalable solution is a federated computational governance model, often referred to as a hub-and-spoke architecture. I would explain that we must centralize the infrastructure, but decentralize the ownership. The central IT hub provides the unified catalog, the automated data quality tooling, and the strict security perimeters. However, the business unit spokes are empowered to own their specific data products, define their local glossary terms, and manage their own quality within those central guardrails. This gives IT the absolute security control they require, while giving the business the speed and autonomy they demand. Pro tip: explain this to the board using the highway system analogy. The central IT team builds the roads, paints the lanes, and installs the speed cameras' centralized infrastructure. but the business units are the drivers who decide where the cars are going and what cargo they carry. Decentralized ownership.
Scenario 325. The board is eager to deploy generative AI globally to reduce operational costs, but the chief legal officer is terrified of copyright lawsuits, deepfake liabilities, and discriminatory algorithms destroying the corporate brand. How do you build an executive strategy for responsible AI governance that allows ethical scaling?
Answer: an executive strategy for responsible AI must balance aggressive deployment with deterministic safety boundaries. I would establish this ethical AI framework. 1. Mandate verifiable data provenance. Require strict, auditable tracking of all training data origins, ensuring no copyrighted or unconsented materials are ever ingested into enterprise models. 2. Enforce algorithmic fairness audits. Deploy automated bias detection monitors that continuously evaluate AI outputs for demographic skew blocking models that deviate from equal opportunity thresholds. 3. Deploy AI safety gateways. Route all incoming prompts and outgoing AI responses through a secondary evaluator model programmed to instantly block toxic, unethical, or hallucinatory responses. 4. Implement deterministic kill switches. Ensure that every autonomous AI agent or model has a hard-coded, human-in-the-loop shutdown mechanism that can instantly sever its database access if anomalous behavior is detected. Pro tip: require an AI nutritional label or model card for every enterprise model. This simple, one-page document explains the model's intended use, its known biases, and its training data sources in plain English, providing the board and legal teams with complete transparency before signing off on deployment.
Scenario 326. Executive leadership is refusing to use standard enterprise BI tools because they do not know which dashboards contain accurate data versus sandbox experiments. They request a single, easily understandable trust score for enterprise data. How do you design and calculate this metric?
Answer: an executive data trust score must aggregate complex technical metrics into a single, intuitive percentage. The trust score can be weighted differently for different business domains. For example, finance dashboards may prioritize lineage and quality more heavily than exploratory analytics. I would calculate this score using 4 weighted pillars. 1. Data freshness timeliness. Measure the exact latency of the pipeline. If a daily financial report hasn't been updated in 48 hours, the trust score drops significantly. 2. Data quality validity and completeness. Aggregate the automated testing results for null values, schema compliance, and format accuracy from the underlying data warehouse. 3. Lineage integrity traceability. Evaluate whether the dashboard is fed by certified, upstream production tables or if it relies on broken, undocumented manual spreadsheet uploads. 4. Stewardship certification governance. Award premium weighting to datasets that have been manually reviewed, approved, and officially badged by a designated business domain owner. Pro tip: push this trust score directly into the consumption UI. Integrate your catalog with tools like Tableau or Power BI so that prominent trust score. 98% badge appears directly on the executive dashboard header. If a pipeline breaks and the score drops below 80%, visually gray out the dashboard to prevent executives from making decisions on corrupted data.
Scenario 327. Your enterprise data volume is growing by 40% year over year, and new AI products are launching monthly. However, the CFO has instituted a strict hiring freeze. How do you use AI, automation, and organizational strategy to scale the governance program across the enterprise without growing your headcount?
Answer: I would scale the program by shifting entirely from manual data stewardship to active metadata automation and embedded engineering practices. First, we deploy LLMs to automatically draft business glossary definitions and classify sensitive PII, transforming our few human stewards into fast review and approve editors rather than manual authors. Second, we implement policy as code directly into the software engineer's CI and CD pipelines. By forcing automated data quality linters and schema validators to check code before it compiles, we effectively turn every software developer into a data steward without altering their job title. We automate the enforcement, allowing a tiny central team to govern a massive global footprint. Pro tip: your most powerful, untapped data stewards are your software engineers. If you provide them with automated command line interface CLI tools that catch data contract violations before deployment, you embed governance at the absolute point of creation, scaling your coverage infinitely without hiring a single new governance analyst.
Category 19 Conclusion.
Mastering executive and boardroom scenarios demonstrates that you are not just a technologist but a business leader. By translating metadata and lineage into hard dollar FinOps savings, proving regulatory risk avoidance to investors, and dissolving destructive C-suite turf wars, you secure the ultimate currency of data governance. Executive trust. When the board trusts your strategy, budget and adoption organically follow.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass. You send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Transition from Category 19 to Category 20.
A perfect boardroom strategy eventually collides with the chaotic reality of enterprise architecture. In the modern data stack, challenges do not exist in neat, isolated silos. A data quality failure triggers an AI hallucination, which violates a privacy law, which breaks a data contract in a streaming pipeline. We must now synthesize everything we have learned to solve massive, multi-dimensional problems. Welcome to Category 20, Enterprise Cross-Domain Governance.
Category 20. Enterprise Cross-Domain Data Governance, Scenario Combinations.
Cross-domain scenarios are the ultimate test of a principal architect. These scenarios combine master data management, generative AI, real-time streaming, and global privacy laws into single, high-stakes incidents. They mirror the exact, compounding complexity of real-world enterprise failures. To solve them, you must weave together metadata, security, architecture, and stewardship into unified, automated solutions.
Category 20. Enterprise Cross-Domain Data Governance Scenarios 328 to 345.
Here are the 18 compounding, cross-domain scenarios we will untangle in this category. Scenario 328. Designing AI governance for real-time streaming data under strict privacy regulations. Scenario 329. Governing self-service analytics across multi-cloud data mesh platforms. Scenario 330. Combining master data management, generative AI, and regulatory explainability. Scenario 331. Intervening when poor data quality causes autonomous AI to corrupt financial reports. Scenario 332. Preventing AI copilots from indexing unclassified files and expanding shadow data systems. Scenario 333. Maintaining end-to-end data lineage across disconnected edge IoT platforms. Scenario 334. Balancing hyper-automated AI processing with human-in-the-loop data stewardship. Scenario 335. Combining FinOps, data observability, and governance to reduce exploding cloud costs. Scenario 336. Scaling federated governance architectures while meeting strict global privacy laws. Scenario 337. Managing incident response when autonomous governance makes the wrong production decision. Scenario 338. Presenting complex AI bias and explainability metrics effectively to the executive board. Scenario 339. Governing third-party AI vendors and APIs across multiple international jurisdictions. Scenario 340. Preventing metric conflicts across dynamic semantic layers and self-service BI tools. Scenario 341. Managing and enforcing data contracts across real-time streaming platforms. Scenario 342. Driving policy as code adoption at scale without triggering severe developer resistance. Scenario 343. Using active metadata and AI lineage mapping to survive strict regulatory audits. Scenario 344. Governing mathematically synthetic healthcare data exclusively for AI model training. Scenario 345. Balancing aggressive responsible AI governance with the need for rapid enterprise innovation. Total 18 cross-domain scenarios. Let's dive into Scenario 328.
Scenario 328. A retail banking client uses real-time Kafka streams to feed a personalization AI model. However, privacy auditors flag that highly sensitive customer PII is passing through the stream unmasked, violating GDPR. How do you design AI governance for real-time streaming data under strict privacy regulations?
Answer: governing real-time AI ingestion streams requires shifting privacy controls to the message broker layer before the model ever sees the data. I would execute this architecture. 1. Deploy in stream dynamic masking. Utilize stream processing engines like KSQLDB or Flink to instantly detect and mask or tokenize PII payloads within the Kafka topic in milliseconds. 2. Implement real-time consent filtering. Connect the stream processor directly to the centralized consent ledger, automatically dropping packets for users who have opted out of algorithmic profiling. 3. Enforce ephemeral AI memory. Configure the downstream personalization AI so it processes the masked streaming context only in volatile memory, structurally preventing it from writing the data to long-term storage. 4. Execute schema registry guardrails. Mandate that all streaming producers explicitly define the privacy metadata tags inside the Confluent schema registry. If a payload arrives untagged, the stream automatically quarantines it. Pro tip: do not wait for streaming data to land in a data warehouse before masking it for AI. By implementing masking at the Kafka topic level, you ensure that the AI model is mathematically incapable of ingesting or memorizing raw customer PII.
Scenario 329. Your enterprise has fully embraced a data mesh architecture distributed across AWS, Azure, and Google Cloud. Business analysts are demanding self-service analytics across these domains, but the security team is blocking cross-cloud querying due to fragmented access policies. How do you govern self-service analytics across a multi-cloud data mesh?
Answer: I would resolve this cross-cloud gridlock by establishing an abstracted governance and virtualization layer. First, we decouple access control from the native cloud providers by deploying a centralized attribute-based access control back engine. This engine reads the user's Active Directory tags and instantly translates them into local AWS IAM or Azure RBAC policies. Second, we implement a data virtualization tool like Starburst or Denodo combined with a unified enterprise catalog. Analysts query the virtualization layer using standard SQL, and the engine automatically translates the query, applies the centralized masking rules, and fetches the data from the respective cloud domain without physically moving the underlying files. Pro tip: in a multi-cloud data mesh, never try to manually sync security groups across AWS, Azure, and GCP. The only scalable solution is policy as code. Write your access rule once in your central orchestrator, and let the software push the technical execution down to the respective cloud's native compute engine.
Scenario 330. Your Master Data Management (MDM) team successfully deployed generative AI to automatically identify and merge duplicate global supplier records. However, a regulator audits a complex merger of two sanctioned entities and demands a deterministic explanation of exactly why the AI merged them. The team cannot explain the LLM's reasoning. How do you combine Gen AI with regulatory explainability in MDM?
Answer: I would immediately restructure the architecture to separate probabilistic AI generation from deterministic MDM execution. Generative AI is highly effective at identifying patterns, but it is fundamentally unexplainable for strict regulatory audits. I would reconfigure the LLM to act strictly as a match recommender. The AI evaluates the suppliers and outputs a match confidence score along with a structured, natural language explanation of its findings. However, the AI is blocked from executing the database merge. A deterministic, rules-based survivorship engine processes the AI's recommendation, and for any high-risk or sanctioned entity, a human data steward must manually click approve, logging the AI's reasoning text permanently into the MDM audit vault. Pro tip: never allow an LLM to blindly issue DML commands like update or merge to your master database. AI should surface the intelligence, but standard, auditable code and human stewards must pull the execution trigger.
Scenario 331. An autonomous AI forecasting agent is authorized to write quarterly revenue predictions directly into an executive dashboard database. Suddenly, an upstream ETL job drops 20% of the European sales data. Because there are no data quality checks, the AI ingests the broken data and overwrites the dashboard with disastrously low revenue forecasts, creating boardroom panic. How do you intervene?
Answer: intervening in autonomous AI corruption requires deploying immediate system rollbacks followed by strict ingestion circuit breakers. I would execute these steps. 1. Execute immediate state rollback. Isolate the AI agent's write access and utilize Snowflake's time travel or database transaction logs to instantly revert the executive dashboard table to its pre-corrupted state. 2. Deploy upstream data contracts. Enforce strict semantic contracts on the ETL pipeline feeding the AI. If record volume drops by more than 5%, the pipeline automatically fails before reaching the model. 3. Implement AI ingestion circuit breakers. Configure the AI agent's ingestion gateway to independently profile incoming datasets, instantly pausing inference if it detects a massive statistical deviation from normal operating baselines. 4. Mandate output anomaly thresholds. Constrain the AI's write capabilities. If the AI agent attempts to publish a revenue forecast that deviates by more than 10% from the previous quarter, it must route to a human finance steward for validation. Pro tip: establish poison pill alerting for autonomous systems. The moment a critical data quality check fails in your primary warehouse, an automated webhook must fire directly to your AI agents, instantly severing their read and write access until the data engineering team clears the incident.
Scenario 332. Your enterprise deployed a highly capable internal AI copilot. Employees discover that they can connect the copilot directly to their local OneDrive folders, unclassified SharePoint sites, and personal spreadsheets, effectively bypassing the corporate data catalog and creating a massive, invisible web of shadow data querying. How do you govern this?
Answer: I would govern this shadow expansion by establishing strict AI retrieval firewall semantic firewall and locking the copilot's retrieval boundary exclusively to the certified enterprise catalog. Copilots act as massive search engines. If you allow them to index personal endpoints, you lose all data visibility. I would configure the AI's orchestration layer to strictly reject any ad hoc local file uploads or unclassified SharePoint connections. Instead, all data must first be registered, tagged with sensitivity labels, and scanned for PII in the central data catalog before the RAG system's vector database is legally permitted to index it. Pro tip: integrate your AI copilot with your data loss prevention DLP endpoint agents. If a user attempts to paste a raw, uncatalogued CSV file full of customer data directly into the chat prompt, the DLP agent should instantly block the text and display a warning, routing the user to the official data onboarding workflow.
Scenario 333. A global logistics company needs to trace data from a physical temperature sensor on a shipping container through an edge processing gateway, across a cellular network, and into an aggregated cloud dashboard to prove pharmaceutical cold chain compliance. Traditional metadata tools lose the lineage at the edge. How do you maintain end-to-end lineage across disconnected edge IoT platforms?
Answer: bridging edge to cloud lineage requires injecting metadata directly into the physical transmission payload. I would design the architecture as follows. 1. Inject edge lineage headers. Configure the physical IoT sensors to inject their unique device identity and active firmware version directly into the header of every MQTT telemetry message. 2. Deploy lightweight open lineage at the edge. Install lightweight lineage emitters on the regional edge gateways, documenting exactly when and how the raw sensor strings were aggregated into micro batches. 3. Stitch cloud ingestion logs. As the MQTT payloads hit the cloud ingestion broker like AWS IoT Core, capture the metadata headers and log the edge to cloud translation event. 4. Centralize in the enterprise knowledge graph. Push the edge events and the cloud data warehouse logs into a single graph database, creating an unbroken visual chain from the physical shipping container to the compliance dashboard. Pro tip: physical to logical lineage is extremely difficult. The secret is ensuring the hardware ID survives the entire journey. Never strip the physical sensor ID during your cloud ETL cleaning process. Carry it all the way to the final dashboard as a hidden column to ensure absolute auditability.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass. You send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 334. Your data stewardship team is deeply fearful that aggressive new AI automation initiatives will replace their jobs, causing them to passively resist adopting new metadata tools. Conversely, leadership wants to automate 100% of data governance to cut costs. How do you balance hyper-automated AI processing with human-in-the-loop data stewardship?
Answer: I would resolve this tension by deploying a strategy of augmented stewardship rather than total replacement. I would demonstrate to leadership that AI cannot be held legally accountable for compliance failures, meaning human stewards are still a regulatory requirement. I would then configure the AI to handle the 80% of repetitive, low-value tasks, such as auto-tagging column names, drafting basic glossary definitions, and resolving minor duplicate records. This elevates the human stewards to focus exclusively on the 20% of high-value tasks, resolving complex departmental data conflicts, signing off on ethical AI use cases, and managing high-risk regulatory exceptions. Pro tip: frame the AI as the junior analyst. Explain to your stewardship team that the AI will do the heavy lifting of drafting the paperwork, but the senior steward will always hold the final approve or reject authority. This immediately shifts their perspective from fear of replacement to adopting a powerful productivity tool.
Scenario 335. The Chief Financial Officer identifies that Snowflake and Databricks cloud compute costs have exploded by 300% over the past year. An audit reveals massive pipeline duplication, where different teams run identical massive ETL jobs daily without realizing it. How do you combine FinOps, data observability, and governance to reduce these exploding cloud costs?
Answer: stopping massive cloud compute waste requires merging technical lineage with financial billing APIs. I would execute this cost reduction framework. 1. Map technical lineage to FinOps cost attribution. Integrate your data observability tool with your cloud billing API. Trace every DBT model and ETL job on the lineage map and tag it with its exact daily run cost. 2. Identify pipeline duplication. Utilize the active metadata catalog to flag high-cost or identical output pipelines, identifying where multiple departments are calculating the exact same metrics independently. 3. Deprecate unused expensive assets. Cross-reference dashboard viewing logs with upstream pipeline costs. If a $5,000 per month pipeline feeds a dashboard that hasn't been opened in 60 days, automatically pause the ETL job. 4. Enforce compute chargebacks. Transition from a central IT budget to decentralized accountability. Route the specific cloud costs of a pipeline directly to the business domain owner's budget, forcing them to self-govern their queries. Pro tip: calculate the cost per query and inject it directly into the analyst's workspace. If an analyst sees a pop-up warning stating, "This unoptimized query will cost $45 to run," they will naturally rewrite their SQL to be more efficient, embedding FinOps directly into user behavior.
Scenario 336. Your organization operates a massive federated data mesh, but global privacy teams warn that delegating data ownership to local domains is violating strict cross-border residency laws like GDPR and LGPD. How do you scale federated governance architectures while meeting strict global privacy laws?
Answer: I would enforce privacy compliance through a global policy, local execution architecture using policy as code. In a federated model, domain owners should not interpret international law. The Central Privacy Office writes access and masking policies, for example. EU data cannot leave the EU in a centralized orchestrator. These policies are dynamically pushed down to the local query engines like Snowflake or Databricks within each domain. This guarantees that no matter how decentralized the domains become, it is mathematically impossible for a local data product owner to inadvertently violate cross-border data transfer restrictions. Pro tip: use data residency tags as mandatory metadata at the point of ingestion. If a domain creates a dataset without a verified country of origin tag, the CI and CD pipeline structurally blocks the dataset from being queried or shared across the mesh.
Scenario 337. An autonomous active metadata system falsely flags a critical, high-volume production sales table as stale and unused, automatically revoking access for the entire marketing analytics department and causing a multi-million-dollar campaign to fail. How do you manage incident response when autonomous governance makes the wrong production decision?
Answer: remediating a destructive autonomous governance action requires immediate rollback capabilities and a recalibration of the AI's execution boundaries. I would execute these steps. 1. Execute immediate state reversal. Trigger the active metadata engine's emergency rollback API to instantly restore the previous day's permissions and tags, unblocking the marketing team. 2. Audit the telemetry failure. Investigate the system logs to identify why the active metadata crawler failed to register the massive query volume, for example, checking if the marketing BI tool service account was accidentally excluded from the audit log. 3. Downgrade to human in the loop. Temporarily demote the autonomous system from execution mode to recommendation mode, forcing all deprecation tags to be manually approved by a steward until the root cause is resolved. 4. Implement high-risk circuit breakers. Code a hard threshold into the active metadata engine, preventing it from altering permissions on any table explicitly flagged with a Tier 1 critical metadata tag. Pro tip: never grant an autonomous governance system hard delete permissions. Autonomous systems should only execute soft deletes or access revocations, leaving the physical data intact, so human administrators can instantly reverse the action during a false positive incident.
Scenario 338. The board of directors is deeply concerned about brand damage from algorithmic bias and demands a report on the fairness of your customer-facing AI models. The data science team provides dense, unreadable spreadsheets filled with SHAP values and loss curves. How do you present complex AI bias and explainability metrics effectively to the executive board?
Answer: I would translate these deep learning mathematical outputs into an algorithmic risk and fairness scorecard. Executives do not need to understand SHAP values. They need to understand risk exposure. I would present two specific KPIs. The demographic parity ratio, proving our models do not systematically deny services to protected classes, and the explainability coverage rate, proving what percentage of automated decisions can be legally defended. I would pair this with a heat map showing which business units are running high-risk models, proving to the board that we have active, measurable guardrails protecting the corporate brand. Pro tip: always use a headline incident to frame the presentation. Remind the board of a competitor who was recently fined millions for AI bias, and use your scorecard to demonstrate exactly how your governance framework mathematically prevents that specific incident from happening here.
Scenario 339. Your enterprise uses 3 different third-party AI vendors to process customer support tickets. Because the vendors host models in the US, UK, and India, your legal team is terrified of cross-border PII leakage and IP theft. How do you govern third-party AI vendors and APIs across multiple international jurisdictions?
Answer: governing third-party AI requires establishing secure data egress perimeters and enforcing zero retention contracts. I would deploy this architecture. 1. Enforce zero retention API contracts. Execute legally binding agreements that the vendor cannot log, persist, or use your corporate payload data to train their future foundational models. 2. Deploy regional API gateways. Route all AI requests through localized API gateways, for example, an EU gateway for European customers to ensure data is processed in the correct residency zone before hitting the vendor. 3. Implement in-flight PII redaction. Utilize data loss prevention DLP proxies to dynamically scrub or tokenize names, account numbers, and addresses from the prompt before the payload leaves your corporate network. 4. Monitor vendor model drift. Continuously test the third-party API against a gold standard benchmark dataset to ensure the vendor hasn't silently updated their model in a way that degrades your customer experience. Pro tip: trust but verify. Do not rely entirely on the vendor's zero retention promise. Conduct regular red team data audits by injecting dummy canary data into your vendor prompts, and monitor the dark web and public internet to see if that unique dummy data ever leaks into the public domain.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Scenario 340. A decentralized data strategy allowed the marketing team to adopt Tableau and the finance team to adopt Power BI. Each team built their own semantic layers, resulting in 2 conflicting definitions of gross margin and completely eroding executive trust. How do you prevent metric conflicts across dynamic semantic layers and self-service BI tools?
Answer: I would resolve this by implementing a headless semantic layer architecture. The conflict exists because calculation logic is trapped inside the visualization tools. I would strip the business logic out of Tableau and Power BI, centralizing the metric definitions in a single, version-controlled repository like dbt semantic layer or cube. Both BI tools are then reconfigured to query this central engine via API. When the definition of gross margin is updated in the central code repository, the change instantly and uniformly propagates to every dashboard in the company, guaranteeing a single version of the truth. Pro tip: treat metrics like software. Mandate that any change to a Tier 1 corporate KPI requires a pull request PR in GitHub, forcing the data steward to formally approve the formula modification before the new metric reaches the executive dashboards.
Scenario 341. Data engineers complain that standard, static data contracts are impossible to maintain on real-time streaming platforms like Kafka, resulting in downstream analytical models, breaking every time a producer adds a new JSON field. How do you manage and enforce data contracts across real-time streaming platforms?
Answer: governing streaming contracts requires enforcing schema compatibility at the message broker layer rather than the database layer. I would implement these controls. 1. Deploy an active schema registry. Mandate that all streaming producers register their payload structures using Avro or Protobuf in a centralized registry before publishing to the topic. 2. Enforce backward compatibility rules. Configure the registry to automatically reject any schema evolution, like dropping a mandatory column that breaks backward compatibility for downstream consumers. 3. Implement dead letter queuing. Set up the stream processor to instantly divert any message that violates the active data contract into a quarantine topic, preventing malformed JSON from crashing the pipeline. 4. Automate contract violation alerts. Integrate the dead letter queue with the data observability platform to immediately page the producing engineering team when their application violates the agreed schema. Pro tip: distinguish between breaking and non-breaking changes. Adding a new, optional column to a JSON payload should be allowed to flow through the stream without failing the contract, giving developers agility while maintaining strict protection over existing fields.
Scenario 342. Your security and governance teams have designed an elegant policy as code framework using Open Policy Agent (OPA), but the software engineering teams refuse to adopt it, claiming it adds unnecessary complexity to their deployments. How do you drive policy as code adoption at scale without triggering severe developer resistance?
Answer: I would drive adoption by hiding the complexity and integrating the policies invisibly into their existing workflows. Developers resist policy as code when they are forced to learn a new language like Rigo or navigate a separate governance UI. Instead, I would embed the OPA checks directly into their existing CI and CD pipelines as automated linters. If a developer attempts to deploy a database table without an owner tag, the pipeline simply fails the build with a clear, clickable error message showing the exact one-line fix required. By making governance a seamless, automated part of the software compilation process, compliance becomes invisible. Pro tip: provide a governance-in-a-box repository. Give developers pre-written Terraform templates that already include all the required compliance tags, logging configurations, and security guardrails. Developers will gladly use your compliant templates if it saves them hours of coding.
Scenario 343. A federal regulatory agency initiates a surprise audit, giving your organization 48 hours to prove the data provenance of a highly sensitive compliance report. Legacy manual mapping would take weeks. How do you use active metadata and AI lineage mapping to survive strict regulatory audits?
Answer: surviving rapid regulatory audits requires relying entirely on automated, system-generated evidence rather than human memory. I would execute this audit response. 1. Generate the dynamic lineage graph. Query the active metadata catalog to automatically trace the report's underlying tables backward through every transformation hop down to the raw ingestion sources. 2. Export the transformation audit trail. Use AI-driven SQL parsers to instantly translate the complex database views and stored procedures into human-readable business logic for the auditors. 3. Compile policy enforcement proof. Export the system access logs correlated directly to the lineage graph, proving mathematically that only authorized personnel access the data during its lifecycle. 4. Present a certified knowledge graph. Hand the auditors an interactive map linking the final report to its certified business glossary terms, proving the data adheres to approved corporate definitions. Pro tip: regulators distrust manual Excel diagrams because they are easily forged or outdated. Presenting an automated, system-generated lineage graph directly from your active metadata platform establishes immediate trust, as it proves your governance is a living, infrastructure-level reality.
Scenario 344. To train a new clinical diagnostic AI without violating HIPAA, the medical data science team generates a massive synthetic dataset. However, the Governance Council is concerned that the math used to generate the data might subtly expose real patient outliers. How do you govern mathematically synthetic healthcare data exclusively for AI model training?
Answer: I would govern this synthetic data by implementing strict privacy enhancing technologies PETs, and adversarial validation gates. Synthetic data is not automatically safe. Before the dataset is approved for model training, I would require the data science team to execute a formal differential privacy evaluation, mathematically guaranteeing that the addition or removal of a single real patient's record does not noticeably change the synthetic output. Furthermore, I would engage an internal red team to perform membership inference attacks against the synthetic set to ensure no real identities can be reverse engineered. Only after passing these two adversarial tests does the dataset receive a certified synthetic metadata tag. Pro tip: treat synthetic healthcare data as an asset with a strict time to live TTL. As AI de-anonymization techniques rapidly advance, a synthetic dataset considered safe today might be crackable in 2 years. Mandate that all synthetic datasets be automatically purged and regenerated annually using the latest encryption standards.
Scenario 345. The CEO demands that the company launch a suite of generative AI tools to stay ahead of market competitors, but the chief risk officer wants to pause all launches to conduct multi-month ethical AI reviews, creating a massive boardroom deadlock. How do you balance aggressive, responsible AI governance with the need for rapid enterprise innovation?
Answer: balancing rapid innovation with strict risk management requires shifting from bottleneck reviews to an automated tiered risk deployment model. I would establish this framework. 1. Implement an AI risk triage matrix. Categorize AI use cases instantly based on impact. A coding assistant for engineers is low risk and bypasses manual review, while an automated customer loan decision is high risk and requires full board approval. 2. Deploy pre-vetted innovation sandboxes. Provide data scientists with isolated cloud environments pre-loaded with scrubbed, certified synthetic data, allowing them to innovate instantly without touching real PII. 3. Enforce automated guardrails at deployment. Integrate AI safety evaluators directly into the deployment pipeline to automatically scan for prompt injections and bias, replacing manual security audits with code-level assertions. 4. Establish post-deployment observability. Allow rapid deployment of medium-risk models by agreeing to monitor their outputs heavily in production, establishing automated kill switches if the model begins hallucinating. Pro tip: the best way to align the CEO and the CRO is to use the brakes on a race car analogy. We are not building a comprehensive, responsible AI framework to slow the company down. We are building superior brakes so the engineering team can safely drive at 200 miles per hour.
Category 20 Conclusion.
Mastering enterprise cross-domain governance proves that you can operate at the absolute highest level of architectural complexity. By untangling compounding failures, where a streaming data latency issue triggers an AI bias alert that violates a global privacy law, you demonstrate the ability to see the enterprise as a unified ecosystem. This is the difference between managing a database and governing a multi-billion-dollar digital enterprise.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Transition from Category 20 to Category 21.
We have solved the cross-domain challenges of today. Now, we must govern the architectures of tomorrow that are already being deployed by industry leaders like Snowflake, Databricks, and OpenAI. The paradigm has shifted. We no longer move data to the applications. We bring the applications and AI directly to the data. We now enter the bleeding edge of enterprise architecture. Category 21. Hyper-modern data governance.
Category 21. Category 21. Next-generation enterprise data governance, hyper-modern data governance scenarios.
This category is not futuristic. It is happening right now. Every major enterprise is racing to adopt data clean rooms, zero-copy sharing, and retrieval-augmented generation RAG ecosystems. These scenarios test your ability to govern data monetization, secure vector embeddings, and navigate the strict legal mandates of the EU AI Act and DORA. This is the new baseline for elite principal architects.
Category 21. Category 21. Next-generation enterprise data governance, hyper-modern data governance scenarios 346 to 362.
Here are the 17 hyper-modern and next-generation data governance architectural scenarios we will master in this category. Scenario 346. Governing enterprise data clean rooms without physically moving data. Scenario 347. Securing zero-copy data sharing and Snowflake native apps. Scenario 348. Implementing compliance and transparency for high-risk AI under the EU AI Act. Scenario 349. building a unified framework for DORA, the EU AI Act, and cyber resilience. Scenario 350. Stopping RAG systems from exposing confidential data via poor retrieval security. Scenario 351. Preventing sensitive PII leakage through reverse-engineered vector embeddings. Scenario 352. Eliminating unauthorized and stale document responses in enterprise RAG systems. Scenario 353. Governing vector search metadata quality to drastically reduce AI hallucinations. Scenario 354. Designing governance to support enterprise data as a service monetization. Scenario 355. Preventing re-identification attacks in commercial data products and APIs. Scenario 356. Designing governance boundaries for global enterprise data marketplaces. Scenario 357. Mitigating massive copyright infringement risks in LLM training data. Scenario 358. Proving strict dataset provenance for large language model pre-training. Scenario 359. Tracking intellectual property lineage across multi-stage AI training pipelines. Scenario 360. Preventing synthetic AI data from accidentally reproducing proprietary content. Scenario 361. Governing enterprise AI agents that continuously access external vector stores. Scenario 362. Ensuring RAG systems perfectly inherit and enforce source system security policies. Total 17 hyper-modern scenarios. Let's dive into Scenario 346.
Scenario 346. Your marketing and finance teams want to collaborate with an external retail partner using a data clean room to bypass third-party cookie deprecation. However, the legal team is terrified of exposing raw customer purchasing histories. How do you govern data collaboration where data is queried but never physically moved?
Answer: governing data clean rooms requires shifting from storage perimeter security to mathematical query constraints. I would establish this collaborative governance framework. 1. Enforce zero-copy architecture. Configure the clean room so both organizations leave their raw data in their respective cloud warehouses, strictly linking them via secure, read-only references. 2. Establish query-level restrictions. Programmatically block select star commands. The clean room must only permit pre-approved aggregate queries, such as count or SUM, ensuring raw row-level data is never exposed to the partner. 3. Deploy differential privacy noise. Inject mathematically calibrated noise into the aggregate outputs. This guarantees that the partner cannot run rapid, repeated queries to isolate and re-identify a specific individual's purchasing behavior. 4. Audit output egress. Implement an automated gateway that logs exactly what aggregated insights were exported by the partner, mapping the output directly back to the active legal data sharing agreement. Pro tip: implement minimum thresholds on all clean room queries. If a partner's query results in an audience segment smaller than 100 people, the system should automatically block the result. Small cohorts are highly vulnerable to re-identification attacks.
Scenario 347. Your enterprise utilizes Snowflake-native apps to purchase and run third-party machine learning models directly on top of your proprietary data. The security team is panicking because they cannot inspect the vendor's proprietary application code, fearing it might secretly exfiltrate your corporate data. How do you govern zero-copy data sharing and native apps?
Answer: I would secure this architecture by governing the application's infrastructure boundary rather than auditing its proprietary code. The paradigm of native apps is bringing the app to the data. I would enforce strict network egress policies within our Snowflake environment, structurally blocking the native app from making external API callouts to the public internet or communicating back to the vendor's servers. The vendor's model can read our data, process it, and output the insights into a designated internal table, but because the egress port is locked, it is mathematically impossible for the app to exfiltrate our proprietary data out of our cloud perimeter. Pro tip: treat data sharing and native apps like internal database users. Apply standard role-based access control RBAC and dynamic data masking policies directly to the app role. The third-party app should only ever interact with masked or tokenized views of your PII, never the raw tables.
Scenario 348. The EU AI Act is now fully enforced. Your organization uses a proprietary machine learning model to evaluate candidate resumes and make automated hiring recommendations. Regulators classify this as a high-risk AI system and demand proof of governance, threatening massive global revenue fines. How do you implement governance for high-risk AI?
Answer: complying with the EU AI Act requires transforming opaque algorithms into highly transparent, documented, and actively monitored systems. I would implement these four mandates. 1. Establish conformity assessments. Conduct and formally document a rigorous risk assessment prior to deployment, proving that the training datasets are free from systemic demographic bias. 2. Deploy mandatory human oversight. Hardcode a human-in-the-loop circuit breaker into the hiring pipeline. The AI can only generate a recommendation score. A human recruiter must formally approve all final rejection decisions. 3. Maintain an active model registry. Store an immutable snapshot of the specific model version, the exact training data lineage, and the hyperparameter configurations for regulatory audits. 4. Enforce output traceability. Log every individual resume recommendation alongside the mathematical feature, weights like SHAP values that drove the decision, guaranteeing complete post-decision explainability. Pro tip: under the EU AI Act, continuous monitoring is mandatory for high-risk systems. You must implement automated drift detection that alerts your risk council the moment the model's hiring recommendations deviate from historical demographic baselines, proving active corporate oversight.
Scenario 349. Your European financial institution is deploying third-party generative AI models for real-time fraud detection. You must simultaneously comply with the Digital Operational Resilience Act (DORA) and the EU AI Act. The board is overwhelmed by these overlapping mandates. How do you build a unified governance framework for cyber resilience and AI risk?
Answer: I would establish a unified algorithmic resilience framework to satisfy both directives simultaneously. DORA mandates operational uptime and third-party ICT risk management, while the EU AI Act mandates algorithmic fairness and transparency. I would satisfy both by implementing strict data contracts and model SLAs with our third-party AI vendors. We legally require the vendor to provide zero retention data processing for privacy and multi-region failover architectures for DORA's cyber resilience. Internally, we deploy an automated proxy gateway that continuously monitors the vendor's API latency and bias metrics, automatically falling back to a deterministic internal rules engine if the vendor's AI fails or hallucinates. Pro tip: treat your AI vendors as critical infrastructure. Under DORA, you cannot blame the vendor if their AI outage takes down your banking app. You must maintain a fully tested exit strategy and offline contingency models to prove to regulators that your bank can survive a catastrophic third-party AI failure.
Scenario 350. An internal RAG-based LLM is deployed to help employees search enterprise policies. However, a junior analyst prompts the model and successfully retrieves synthesized answers based on the CEO's private HR termination plans, causing massive organizational panic. How do you secure RAG retrieval boundaries to prevent confidential exposure?
Answer: this is a catastrophic failure of semantic access control. RAG systems must strictly inherit the permissions of the user prompting them. I would secure the retrieval pipeline using these steps. 1. Enforce document-level metadata tagging. During the vector ingestion phase, ensure every document chunk is tagged with the exact Active Directory security group required to read the original file. 2. Implement pre-retrieval filtering. Configure the vector database to dynamically intercept the user's prompt and append a hard-coded security filter based on their active session token, for example, and clearance underscore level is equal to junior. 3. Deploy semantic re-ranking limits. Ensure the retrieval engine mathematically drops any high-relevance vector chunks from the context window if the user's identity token does not match the chunk's access control list. 4. Audit Copilot query logs. Stream all user prompts and the specific document IDs retrieved by the RAG system into a security incident event management SIEM tool to actively monitor for insider privilege escalation. Pro tip: do not rely on post-retrieval filtering or asking the LLM to ignore sensitive data in the system prompt. LLMs are highly susceptible to prompt injection. The security filter must be executed at the vector database layer times before the text ever reaches the language model.
Scenario 351. Your engineering team converts 10 years of customer support emails into vector embeddings to power a semantic search engine. The security team discovers that researchers can reverse engineer these mathematical embeddings back into raw text, exposing plain text credit card numbers and medical conditions. How do you prevent sensitive PII leakage through vector embeddings?
Answer: I would resolve this vulnerability by treating vector embeddings as highly sensitive derived assets and enforcing a mask before embedding pipeline. It is a dangerous misconception that converting text to numbers anonymizes it. I would deploy a robust named entity recognition (NER) scanner at the very front of our ingestion pipeline. Before any customer email is chunked or sent to the embedding model, the NER tool dynamically redacts all credit card numbers, SSNs, and medical terms, replacing them with generic tokens like redacted_financial. Only the scrubbed text is converted into vectors, ensuring it is mathematically impossible to retrieve or reverse engineer PII from the vector database. Pro tip: treat your vector database exactly like your production relational data warehouse. Apply encryption at rest, strict role-based access control, and regular vulnerability scanning. A compromised vector database is just as catastrophic as a compromised SQL database.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details: 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 352. Your enterprise RAG system is hallucinating dangerous legal advice. The underlying language model is functioning perfectly, but it is retrieving and synthesizing answers based on an outdated, deprecated version of a corporate compliance policy from 3 years ago. How do you prevent unauthorized and stale responses in enterprise RAG systems?
Answer: stale RAG responses are a symptom of disconnected metadata lifecycles. I would govern the vector database freshness using this lifecycle architecture. 1. Implement vector cache invalidation. Integrate your master document repository like SharePoint or Confluence directly with your vector database via webhooks to trigger an instant delete and replace API call the moment a source document is updated. 2. Enforce time to live TTL on chunks. Tag every ingested vector chunk with an explicit expiration date based on corporate retention policies, automatically purging outdated policy chunks from the retrieval index. 3. Inject freshness metadata into prompts. Configure the retrieval engine to pass the last _updated_ date of the retrieved document into the LLM context window, explicitly instructing the AI to warn the user if the source text is over 12 months old. 4. Deploy deprecation filters. Map the vector database to the central data catalog. If a policy document is flagged as deprecated by a data steward, that status must instantly propagate to the vector index to block retrieval. Pro tip: establish version-aware retrieval. If multiple versions of a document exist, structurally force the semantic search engine to apply a heavy mathematical penalty to older document timestamps, ensuring the LLM is always fed the absolute latest version of the corporate truth.
Scenario 353. The newly deployed internal AI copilot is suffering from massive hallucination rates. An audit reveals the root cause. The documents were sliced into arbitrary 500-character chunks during ingestion, severing the context between a policy's title and its exceptions, feeding the LLM fragmented garbage. How do you govern vector search metadata quality to reduce AI hallucinations?
Answer: I would resolve this contextual fragmentation by abandoning dumb character count chunking and implementing a semantic chunking strategy governed by metadata formatting rules. I would collaborate with data engineering to configure the ingestion pipeline to slice documents based on natural structural boundaries, such as markdown headers, paragraphs, or JSON objects. Furthermore, I would mandate metadata enrichment for every chunk. We programmatically append the parent document's title, author, and section header directly into the text of every child chunk before embedding. This ensures that even if a single paragraph is retrieved in isolation, the LLM retains the full structural context of where that information originated, drastically reducing hallucinations. Pro tip: treat your text chunking strategy as a formal data transformation pipeline. Apply standard data quality assertions to your chunks, such as minimum token lengths and required metadata headers, before allowing them to be indexed in the production vector database.
Scenario 354. The CEO mandates a new initiative to package and sell anonymized corporate telemetry data to external hedge funds and research partners as a data-as-a-service platform. The chief legal officer is worried about uncontrolled licensing and IP theft. How do you govern enterprise data monetization safely?
Answer: governing data as a service requires treating datasets as licensed, monitored commercial products. I would design the monetization framework using these 4 pillars. 1. Establish a governed API storefront. Force all external consumers to access the data exclusively through a highly secure API gateway equipped with strict rate limiting, IP whitelisting, and tokenized authentication. 2. Deploy differential privacy noise. Apply mathematical privacy algorithms to all outgoing datasets to ensure that external hedge funds cannot cross-reference the data with public records to reverse engineer specific customer identities. 3. Enforce data licensing contracts. Embed digital terms of use directly into the metadata payloads and require consumers to digitally sign active data processing agreements before the API releases the first byte of data. 4. Implement digital watermarking. Inject unique, invisible cryptographic anomalies into the specific datasets sold to each individual partner, ensuring you can mathematically trace and prosecute any unauthorized reselling of your proprietary data. Pro tip: never monetize raw data drops via FTP or bulk CSV downloads. By restricting monetization exclusively to API endpoints or secure data clean rooms, you maintain the ultimate kill switch to instantly revoke access if a partner violates their licensing agreement.
Scenario 355. Your enterprise is monetizing anonymized consumer transaction data via external APIs. However, the privacy team warns of mosaic attacks, where external buyers might cross-reference your datasets with public voter registries to reverse engineer and re-identify specific individuals. How do you technically prevent re-identification attacks in commercial data products?
Answer: preventing mosaic and re-identification attacks requires shifting from simple masking to mathematical privacy guarantees. I would secure the commercial data product using these 4 controls. 1. Enforce K-anonymity thresholds. Program the outbound data pipeline to suppress any data row where the combination of quasi-identifiers like zip code, age, and gender applies to fewer than K individuals in the dataset. 2. Deploy differential privacy noise. Inject mathematically calibrated noise into the dataset distributions so that the presence or absence of any single individual's record cannot be statistically confirmed by the buyer. 3. Implement dynamic query rate limiting. Configure the API gateway to throttle and audit consumers who run high-frequency, overlapping queries designed to isolate specific edge case profiles. 4. Mandate secure clean room consumption. Refuse raw bulk data transfers. Require buyers to execute their queries inside a governed data clean room, where only highly aggregated, non-identifiable results are allowed to egress. Pro tip: do not rely on removing direct identifiers like names or social security numbers. In modern data science, removing the name column is entirely insufficient. An attacker only needs 3 indirect data points like zip code, birthdate, and gender to uniquely identify 87% of the population.
Scenario 356. The Chief Data Officer is launching a global enterprise data marketplace to allow internal business units and approved external partners to shop for certified datasets. However, IT is concerned about massive data sprawl, uncontrolled access, and untracked cloud compute costs. How do you design the governance boundaries for an enterprise data marketplace?
Answer: I would design the marketplace around a federated publish, centralized consume operating model enforced by automated data access contracts. When a domain team publishes a dataset to the marketplace storefront, they are required to attach strict metadata parameters defining its data quality SLA, pricing or compute cost, and attribute-based access control ABAC tags. When a consumer clicks subscribe on a dataset, an automated workflow evaluates their Active Directory identity against the dataset's ABAC tags. If approved, the system dynamically provisions a secure, read-only view in the consumer's cloud workspace, fully logging the access and routing the cloud compute charge back directly to the consumer's departmental budget. Pro tip: treat marketplace data subscriptions as temporary leases, not permanent grants. Enforce a strict time to live TTL on every approved subscription, for example, 90 days, forcing consumers to automatically re-justify their business need, which actively prunes unused data connections and prevents sprawling access debt.
Scenario 357. Your AI engineering team is actively scraping the internet and ingesting massive third-party text repositories to pre-train a proprietary large language model. The chief legal officer halts the project, warning of massive intellectual property lawsuits and copyright infringement risks. How do you mitigate copyright risks in LLM training data?
Answer: governing intellectual property in AI training pipelines requires strict provenance tracking and automated exclusion gates. I would deploy this copyright mitigation framework. 1. Enforce opt-out metadata scanning. Build an ingestion crawler that programmatically respects robots.txt, AI crawler permission standards, publisher licensing metadata, and standard AI exclusion tags, automatically dropping data from publishers who have opted out of AI scraping. 2. Establish a licensed data registry. Maintain a dedicated, cataloged repository exclusively containing commercially licensed or open-source permissive datasets, physically isolating them from unvetted public data. 3. Deploy automated copyright scanners. Pass all raw text through a similarity matching algorithm designed to detect and quarantine highly recognizable copyrighted passages, code blocks, or proprietary watermarks before training. 4. Log immutable provenance hashes. Generate a cryptographic hash for every document chunk used in the training pipeline, allowing legal teams to definitively prove the exact origin and licensing status of the model's knowledge base. Pro tip: establish a tainted data kill switch. If a third-party publisher successfully sues or demands the removal of their copyrighted content, your governance architecture must have the technical lineage capability to isolate exactly which model weights were influenced by that specific file to execute a targeted machine unlearning routine.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details: 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip: Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 358. An external regulatory body audits your enterprise's newly deployed large language model, demanding absolute proof that no prohibited, unconsented consumer data was used during the pre-training phase. If you cannot prove the provenance of the training set, the model must be destroyed. How do you prove strict dataset provenance for LLM pre-training?
Answer: I would prove compliance by presenting the regulators with a cryptographic model bill of materials (MBOM) mapped to an immutable audit ledger and model cards. During the model's development, I would implement a pipeline where every raw dataset ingested for training must be registered in the Enterprise Data Catalog with a verified consent status metadata tag. We then hash these verified datasets and log the cryptographic signatures directly into the model registry alongside the specific training run ID. This creates an unbroken, mathematical chain of evidence. We can show the auditor the exact model weights, trace them back to the specific training job, and display the underlying data hashes that match exclusively to legally approved, consented catalog entries. Pro tip: do not just document what was included in the model, rigorously document what was times excluded. Providing regulators with audit logs showing that your automated pipeline successfully detected and dropped 50,000 unconsented records proves that your governance guardrails are actively working.
Scenario 359. Your enterprise uses a multi-stage AI training pipeline involving base model fine-tuning, reinforcement learning from human feedback (RLHF), and continuous alignment. The legal team needs to track exactly where a specific piece of highly sensitive intellectual property, IP, was introduced into the model's weights. How do you track IP lineage across complex, multi-stage AI pipelines?
Answer: tracking IP through deep learning transformations requires injecting metadata telemetry into the orchestration pipeline. I would execute this lineage strategy. 1. Tag IP at the chunk level. Before ingestion, ensure the specific sensitive document is structurally tagged with an IP-restricted metadata attribute inside the vector database or training staging area. 2. Emit open lineage training events. Configure the ML pipeline, for example, ML flow, kubeflow to emit a standard lineage event for every fine-tuning job, capturing the exact dataset version and the resulting model artifact. 3. Log RLHF annotator metadata. Track human feedback sessions meticulously, mapping the specific human annotator's identity and their text corrections to the model version to ensure no employee inadvertently typed confidential IP into the reward model. 4. Centralize in the model registry. Stitch these multi-stage hops together in the enterprise catalog, providing a visual graph that shows how a raw proprietary document influenced version 2 of the base model and version 3 of the RLHF alignment. Pro tip: for highly sensitive IP, execute data hashing validation. Generate a hash of the sensitive IP document and actively scan the final model's output distribution. If the exact hash or a near-identical semantic distribution can be prompted out of the model, you have proof of model memorization, and the model must be quarantined.
Scenario 360. To protect privacy, your team uses an AI generator to create a synthetic version of your master customer database. However, during red team testing, security discovers that the synthetic data generator overfitted and accidentally reproduced the exact, real social security numbers of several high net worth customers inside the fake dataset. How do you prevent synthetic AI data from reproducing proprietary content?
Answer: I would prevent this catastrophic memorization risk by deploying adversarial evaluation gates within the synthetic generation pipeline. Synthetic generation models like GANs or diffusion models are highly prone to overfitting on statistical outliers. Before any synthetic dataset is approved for enterprise use, it must pass through an automated distance metric filter. This filter mathematically calculates the nearest neighbor distance between every generated synthetic row and the original real-world seed data. If any synthetic record is found to have a one-to-one match or an unacceptable similarity to a real customer profile, that specific synthetic row is instantly purged from the batch. We only release the dataset once the entire batch satisfies our threshold for differential privacy. Pro tip: actively red team your synthetic data generator. Deploy an adversarial AI agent specifically prompted to execute data extraction attacks against your generator, constantly attempting to trick it into regurgitating exact memorized records. Finding the vulnerabilities yourself is always better than an external auditor finding them.
Scenario 361. Your enterprise deploys internal autonomous AI agents that are programmed to fetch external market research by continuously querying a third-party partner's vector database. Security is concerned that these agents might pull in malicious payloads or unknowingly leak internal prompt context to the external vendor. How do you govern enterprise AI agents accessing external vector stores?
Answer: governing agent to external data queries requires establishing strict API boundaries, payload scrubbing, and semantic firewalls. I would deploy this security architecture. 1. Enforce mutual TLS/MTLS authentication. Ensure the AI agent communicates with the external vector store over a cryptographically secured tunnel, verifying the identities of both the agent and the external endpoint. 2. Deploy semantic prompt firewalls. Route the agent's outbound queries through an internal data loss prevention DLP gateway, automatically redacting any internal corporate identifiers or proprietary context before the prompt reaches the external vendor. 3. Establish inbound schema contracts. Treat the third-party vector payload as untrusted data. Force the inbound retrieve chunks through a strict validation schema to instantly drop malformed responses or hidden malicious code execution strings. 4. Log retrieval payloads. Capture the exact outbound prompt and the exact inbound vector chunk in an immutable corporate audit vault to monitor the third-party relationship for data poisoning attempts. Pro tip: treat external vector stores with the same zero-trust skepticism as the public internet. Never allow an internal AI agent to execute an autonomous business decision, like issuing a buy order based solely on data retrieved from an external vector endpoint, without a deterministic, internal cross-validation check.
Scenario 362. Your organization deploys a retrieval augmented generation RAG assistant connected to your Microsoft SharePoint repository. However, employees discover the AI is summarizing documents they personally do not have access to because the vector database failed to inherit the strict folder-level access control lists ACLs from SharePoint. How do you ensure RAG systems perfectly inherit and enforce source system security policies?
Answer: I would resolve this critical access control failure by implementing late binding authorization and metadata synchronization at the ingestion layer. When documents are chunked and embedded into the vector database, we must program the pipeline to capture the source document's access control lists ACLs and write them directly into the metadata of every single vector node. When a user submits a prompt, the RAG orchestration engine first retrieves the user's active identity token from the enterprise identity provider. The vector database then performs a pre-retrieval filter, mathematically dropping any vector chunks from the semantic search space if the user's identity token does not explicitly match the chunk's inherited ACL metadata. The LLM simply cannot summarize data it is never handed. Pro tip: never rely on system prompts to enforce security. Instructing an LLM with do not summarize documents the user lacks access to is highly vulnerable to prompt injection and hallucination. Security must be enforced deterministically at the database query layer, long before the text reaches the generative model.
Category 21 Conclusion.
Mastering hyper-modern data governance requires a massive architectural paradigm shift. You are no longer securing static perimeters. You are governing mathematical queries, cryptographic provenances, and zero-copy collaboration. By deploying data clean rooms, protecting vector embeddings, and structuring enterprise compliance for high-risk models, you build a defensible, revenue-generating data ecosystem that safely monetizes insights while structurally blocking privacy breaches.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details: 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Transition from Category 21 to Category 22.
We have secured the hyper-modern data architecture, but the ultimate evolution of enterprise data governance involves stepping away from human-centric controls entirely. The enterprise is rapidly becoming a network of interconnected, autonomous digital workers. How do you govern a workforce of machines? We now enter our final and most advanced frontier. Category 22. Enterprise AI Governance Architecture.
Category 22. Enterprise AI Governance Architecture.
This final category focuses on the operational reality of the AI-driven enterprise. This is not speculative. It is the immediate engineering challenge facing every chief data officer today. We will architect governance for model context protocols, tool calling, agent-to-agent collaboration, AI memory retention, automated red teaming, and AI FinOps. Mastering these scenarios establishes you as a true visionary, capable of governing the next decade of enterprise technology.
Category 22. Enterprise AI Architecture 363 to 372.
Here are the final 10 elite-level enterprise AI architecture scenarios we will solve to complete this masterclass. Scenario 363. Governing Model Context Protocol MCP servers, tool calling, and AI connectors. Scenario 364. Designing identity, authentication, and audit controls for autonomous AI agents. Scenario 365. Governing secure agent-to-agent A2A communication using AI policy as code. Scenario 366. Designing AI memory governance for long-term enterprise knowledge retention. Scenario 367. Governing AI evaluation datasets and enterprise benchmarking frameworks. Scenario 368. Building governance for AI red teaming and enterprise AI risk registers. Scenario 369. Governing the enterprise AI supply chain aligned to NIST and ISO control frameworks. Scenario 370. Controlling enterprise AI tool sprawl across co-pilots and business units. Scenario 371. Implementing AI FinOps governance for token usage and inference optimization. Scenario 372. Establishing end-to-end AI output provenance across prompts, retrieval, and generation. Total 10 premium scenarios. Let's dive into Scenario 363.
Scenario 363. Your enterprise AI assistant connects to Salesforce, Jira, SAP, and Snowflake through Model Context Protocol MCP servers, tool calling endpoints, and custom AI connectors. Security discovers that one compromised connector can expose multiple enterprise systems simultaneously. How do you design governance for enterprise tool calling and MCP ecosystems?
Answer: governing enterprise MCP ecosystems and tool calling integrations requires establishing centralized broker layers and granular, least privilege scoping. I would execute this architecture. 1. Deploy dedicated proxy gateways. Route all context protocol requests and tool calls through a unified enterprise API gateway, enabling real-time inspection and logging of every payload traveling to and from the model. 2. Enforce strict tool-level scoping. Restrict MCP servers and AI connectors using OAuth to least privilege scopes, ensuring the agent can only execute specific queries on designated tables, rather than granting broad database access. 3. Implement human-in-the-loop confirmation. Require explicit human approval for any state-changing actions requested via the protocol, such as updating a Jira ticket or modifying a Salesforce record. 4. Establish centralized connection registries. Catalog every active tool endpoint and MCP server connection, formally mapping its specific business purpose, data owner, and certified compliance status in the metadata catalog. Pro tip: treat MCP servers, an AI tool calling endpoints exactly like highly privileged service accounts. Implement strict session token expirations and continuous rotation. If an agent behaves erratically, you can sever the token instantly without bringing down the core application.
Scenario 364. Hundreds of autonomous AI agents execute business workflows across finance, HR, and procurement. Current governance focuses entirely on human identities. How do you assign identities, permissions, accountability, and audit trails to non-human AI workers?
Answer: governing non-human workers requires expanding identity federation to include cryptographic machine identities. I would structure this governance model as follows. 1. Issue cryptographic non-human identities (NHI). Assign every autonomous agent a unique, lifecycle managed identity certificate bound specifically to its operational business unit. 2. Implement dynamic contextual authentication. Enforce strict conditional access policies where agent authentication requires validation of the initiating user's session and the approved operational time zone. 3. Bind agent actions to human sponsors. Structurally mandate that every deployed agent has a designated, named human executive who is legally and financially accountable for its database actions. 4. Log immutable execution telemetry. Stream all agent authentication events, system calls, and payload hashes into a worm-compliant security lake for absolute non-repudiation. Pro tip: avoid shared or generic service accounts for agent swarms. If 5 different supply chain agents use the same database credential, it is mathematically impossible to isolate which specific agent hallucinated and corrupted the master ledger during an incident.
Scenario 365. Multiple enterprise AI agents collaborate to fulfill a customer request. A public-facing support agent hands off sensitive data to a highly privileged backend finance agent to process a refund. How do you govern trust, authentication, approvals, and traceability between autonomous AI agents?
Answer: governing agent-to-agent communication requires establishing a zero-trust inter-agent protocol. I would implement mutual TLS authentication between all interacting nodes, ensuring that Agent A explicitly verifies the cryptographic identity and clearance level of Agent B before transmitting any context. Instead of passing raw, unstructured prompts, agents must communicate using structured, governed data contracts like JSON schemas via a centralized orchestration bus. Furthermore, we enforce strict AI policy as code definitions. If a low-privilege front-end agent attempts to instruct a high-privilege back-end agent to execute a financial transaction, the orchestrator automatically intercepts the payload, evaluates the policy, and triggers a mandatory human-in-the-loop approval gate before the transaction proceeds. Pro tip: implement data passports for A2A payloads. When an agent transfers data, it must append a metadata passport containing the data's sensitivity classification and strict usage instructions. If the receiving agent's policy does not match the passport, the payload is automatically dropped.
Scenario 366. Enterprise copilots store long-term memory about employees and customers to provide highly personalized assistance. However, the compliance team warns this creates a massive liability regarding the right to be forgotten. How do you govern memory retention, deletion, and regulatory compliance?
Answer: I would govern memory by physically separating conversational context from foundational model weights, utilizing an external, metadata-tagged vector database for all long-term memory storage. Every user interaction stored in this semantic memory bank is structurally tagged with a global customer ID and an explicit time-to-live TTL attribute. When a customer invokes their right to be forgotten, or when an employee is terminated, our automated privacy pipeline queries the vector database using these metadata tags and mathematically deletes the exact embedded chunks associated with that individual. This allows the co-pilot to be highly personalized while remaining perfectly compliant. Pro tip: treat conversational memory like a standard transactional database. Implement aggressive data decay policies where routine conversational context is automatically purged after 30 days. Keeping infinite memory does not improve assistant performance. It only exponentially increases your legal discovery footprint.
Scenario 367. Your organization maintains thousands of evaluation prompts to benchmark enterprise models before deployment. However, data scientists are accidentally allowing models to train on these evaluation datasets, creating data contamination and falsely inflated performance scores. How do you govern benchmark datasets?
Answer: governing evaluation data requires total cryptographic isolation from training environments. I would implement the following controls. 1. Enforce cryptographic isolation. Physically isolate evaluation datasets in restricted cloud storage buckets where training orchestration roles have explicit deny permissions. 2. Implement dynamic hash auditing. Generate strict checksums for the evaluation sets and scan all training ingestion pipelines to flag and block overlapping data hashes. 3. Standardize benchmark governance. Require that all evaluation prompt sets are registered in the enterprise data catalog with designated owners and locked semantic versions. 4. Cycle and rotate golden sets. Continuously refresh evaluation data to prevent models from implicitly learning the benchmark over time, ensuring accurate measurement of true generalization. Pro tip: use canary traps in your evaluation datasets. Insert unique, nonsensical strings into the evaluation prompts. If a deployed model generates those specific canary strings during production inference, you have definitive proof that the model was illegally trained on its own test data.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Scenario 368. Almost every large enterprise is creating adversarial testing units. Your AI red team discovers novel prompt attacks capable of bypassing standard safety filters and exposing back-end financial schemas. How do you operationalize governance around continuous AI red team testing?
Answer: operationalizing adversarial testing requires formalizing it as a mandatory pre-deployment governance gate. I would integrate continuous red teaming directly into our CI and CD model pipelines. When developers submit a new model version, it is deployed to a staging environment where the red team uses automated adversarial agents to bombard the system with prompt injections, payload extraction attempts, and jailbreaks. The results are logged into a formal vulnerability scorecard and mapped directly to the enterprise AI risk register. If the model fails to block high-severity attacks, the governance orchestrator automatically halts the production release. Furthermore, we establish an automated feedback loop where successful jailbreak prompts are instantly added to the safety gateway's dynamic block list. Pro tip: do not just red team the model. Red team the underlying data access. Instruct your adversarial engineers to specifically attempt to bypass the retrieval boundaries to pull documents they are not authorized to see. Securing the prompt is useless if the retrieval database permissions are misconfigured.
Scenario 369. Your enterprise models depend on third-party foundational weights, external embeddings, cloud vector databases, plugins, and web connectors. The CISO demands accountability across this fragmented ecosystem. How do you govern the complete AI supply chain in alignment with control frameworks like NIST IRMF and ISO or IEC 42001?
Answer: governing the supply chain requires cryptographic inventory tracking and continuous monitoring. I would deploy this architecture aligned to standard AI control frameworks. 1. Establish an AI bill of materials AI BOM. Require a cryptographic inventory for every deployed system, detailing exact version hashes for base models, libraries, and external plugins. 2. Enforce dependency certification gates. Restrict development environments to only pull packages, embedding algorithms and weights from an internal, pre-scanned, and governed artifact repository. 3. Monitor third-party model drift. Deploy automated shadow testing pipelines that continuously query external vendor endpoints, alerting governance teams if the vendor silently alters their underlying model behavior. 4. Govern egress at the plugin layer. Apply strict data loss prevention DLP proxies to all external plugin connections, ensuring no sensitive proprietary data leaves the corporate boundary during third-party tool execution. Pro tip: third-party dependencies are the biggest blind spot in supply chains. Treat every external plugin call exactly like a high-risk vendor onboarding. If you cannot mathematically prove that the vendor enforces zero retention policies on your payloads, the plugin must be structurally blocked.
Scenario 370. Different business units have independently adopted multiple tools like ChatGPT Enterprise, Claude, GitHub Copilot, Cursor, and internal custom copilots. This tool sprawl has fractured governance and created massive blind spots. How do you establish unified enterprise platform governance?
Answer: I would eliminate this sprawl by deploying a centralized, agnostic enterprise AI gateway. Instead of allowing business units to connect directly to disparate vendor endpoints, all outbound traffic for large language models must route through this unified corporate proxy. This gateway provides a single pane of glass for governance, allowing us to enforce universal data loss prevention (DLP) rules, standardize logging, and manage access entitlements regardless of the underlying model. By providing developers and business users with a single, highly performant gateway that supports all top-tier models, we remove the incentive for shadow adoption while maintaining absolute corporate control. Pro tip: use the gateway to enforce model routing governance. If a user submits a prompt containing sensitive internal financial terms, the gateway should dynamically route that prompt away from external public models and directly to a secure, self-hosted internal model, ensuring data sovereignty without disrupting the user's workflow.
Scenario 371. Following widespread enterprise adoption, your organization's token consumption costs have increased by 500% in 6 months. Compute bills are skyrocketing due to inefficient prompts and redundant queries. How do you implement AI FinOps governance to control token usage and model costs?
Answer: controlling hypergrowth token costs requires mapping consumption metadata directly to financial workflows. I would implement these controls. 1. Deploy token chargeback mechanisms. Connect your gateway logs to the finance billing system, automatically assigning token consumption costs directly to the specific business unit that generated the prompt. 2. Implement dynamic model routing. Use a lightweight orchestrator to evaluate prompt complexity. Simple summarization tasks are routed to cheaper, smaller models, reserving expensive frontier models exclusively for high reasoning workloads. 3. Establish semantic caching. Deploy caching layers that store the responses to frequently asked enterprise questions, serving subsequent identical requests instantly for zero compute cost. 4. Monitor inference ROI. Cross-reference model operational costs against the specific data products they support, decommissioning costly workflows that deliver negligible business value. Pro tip: establish token quotas for non-production environments. Engineers will frequently run massive, unoptimized batch evaluations that consume millions of tokens in minutes. Hard-coding token budget limits prevents accidental runaway scripts from destroying your monthly cloud budget.
Scenario 372. An automated strategic forecast reaches the board of directors, but they question the validity of a highly controversial financial projection generated by the copilot. How do you establish end-to-end AI output provenance to prove exactly which prompts, models, datasets, retrieval sources, and policies contributed to every paragraph?
Answer: I would establish absolute provenance by implementing an output bill of materials using cryptographic lineage tracking. Every time the system generates a final report, the orchestration pipeline automatically appends a hidden metadata ledger. This ledger records the exact Active Directory identity of the prompter, the specific version of the foundational model, the semantic chunks retrieved from the vector database, and the exact timestamps of the execution. When the board questions a specific financial projection, we use this metadata to trace the sentence back to the exact source document and the verified governance as code data contract that allowed its retrieval, turning a black box hallucination risk into a fully defensible, mathematically proven insight. Pro tip: integrate provenance metadata directly into the user interface. Attach a citation toolkit to enterprise copilots so that whenever a user clicks on a generated statistic, a tooltip instantly displays the hyperlink to the verified, certified source document in your data catalog, bridging the gap between generated text and governed truth.
The ultimate data governance masterclass.
You have just completed the most comprehensive, advanced, and grueling data governance curriculum available in the industry. Over the course of these 372 scenarios, You have progressed from mastering core data quality and active metadata to governing enterprise AI, autonomous agents, and production-scale AI platforms. You now understand the full governance lifecycle, from raw data creation at the source to AI-generated business decisions in the boardroom.
The path of the top 1% architect.
The difference between an average data professional and a top 1% enterprise architect is not just knowing how to configure a tool. It is the ability to see the invisible connections across a multi-cloud ecosystem, mathematically prove compliance to a regulator, and justify multi-million-dollar cloud architectures to a skeptical board of directors. You now possess that blueprint. Final call to action. If you have stayed with us through all 3 parts of this masterclass, you are already operating at an elite level. Please smash the like button, leave a comment below with your biggest takeaway, and subscribe to the channel so you never miss an architectural deep dive. For those ready to accelerate their careers, immediately our subscription model linked in the description below. Thank you for your dedication, and I will see you in the next masterclass.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass. You send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
For more exciting tips, tricks, and more importantly, for valuable insights of interviews, please share, like, and subscribe to my channel. It has a lot of valuable information about various insights of interviews. It has a wide range of real-world portfolio projects of various technologies for interviews, and it has wide range of most asked interview questions and answers of various technologies like data science, SAP, AWS, DevOps, and full-stack web development, and more. That will be useful during interviews. It has a wide range of most asked interview questions and answers and real-world portfolio projects of various technologies for freshers, for 2 to 3 years, experienced candidates, and for 5 or above years, experienced candidates to test their skills by knowing most asked interview questions and make themselves ready for interviews.